Hello everybody. I'm audible, visible. Hello, hello, hello. Yes. So finally, I hope everything is perfect, okay? Konjam difficulty irundiruchida, and finally we are here. Yes, yes. So in the reunion when the faster we didn't expect it, right? So I'm so happy that I got my kids back. Very happy. 1 second. Okay. So guys, don't forget to like the session and also share this video with max your friends. Okay. So how about the last physics exam? Yes, Hari, if you are writing Malayalam, you should know proper Malayalam, okay? Yes. Good afternoon, Srimuki, Shamita, Hema, yes, Gayatri, Saravana, yes, good evening. Yes, if you understood, give me a red heart, everybody. I missed the red heart for a long time. Yes. And how are you people? Are you guys ready for the RE-NEET? Okay, yes, of course, this is a hard process, but we should move on, right? Okay, this is a second chance. This is proper execute, we will crack it. You should have the confidence. Yes, I can see a lot of red hearts. And guys, how many of you have already enrolled in our free crash course? Nama app with lots of features. Okay, classes irukum, Insta doubt solving irukum, nama AI help irukum, and also full length test series irukke, assignments irukke. So those who want it, nama description box paatha first link. Okay, and the first link la join paniko, and the you have to just click on it. Enroll. So just for 0 rupees, okay, we are going to enrolled. Yes, very good. I have joined. Very good. Yes, Lakshmi, good evening. Yes, Navyasri. Yes, neurospams. Enrolled. Yes. Hi, Manju is waiting for the sessions. Okay, I saw your comment. I'm good, Lakshmi. I'm good. I'm just excited. Actually, in the class, I could see you people again. No, you people just went after the exam. So I just need to, maybe and the exam we are all missing you people. So adanale maybe has given another opportunity to meet us. But ana konjam harsh reality da. Okay, so let us start the session. Yes, Bunny, if today also if you are not joining, I'll throw you away. Yes, Takshin. Yes, hi. Yes, Milan, we meet again. This is something which is planned. That is why. Yes. Start with fire. Everybody give me some fire. Everybody. And those who are new to this channel, Marakama channel subscribe panikoda. Yena in the channel is not going to disappoint you people, and that is why these many students are waiting for us. Okay, these many students, these many hearts, these many fires were coming for us. It is just because May 3rd varakum how we did or how we were with them. Okay, so and the confidence so and the confidence you should also get. So adikaga marakama channel subscribe panikoda. So now let us just start with the chapter current electricity. Okay, so idhula vanda quick revision irukum. Adikapram we will be going for some question practice. Adikapram again next topic. Adikapram question practice idudha vanda we are going to do. Okay. Yes. Lots of hearts, lots of fire. Very good. Okay, so now we have the current electricity. So adula vanda that cancel need. Okay, so right now nama current electricity da. So current electricity la vanda first topic enada nama electric current, correcta? Electric current. So in the electric current yes, I got it. Vignesh, right? You are coming from which, Nitin? Okay, I got your painting and I was so excited. I have created a beautiful video. Okay, I wanted to share with you actually. Okay, so yes. Yeah, so it is such a beautiful drawing. Okay, even I felt like I'm I mean, looking little bit more beautiful there. Okay. And koncham changes allame irukke right now. Okay, yes, Chennai, yeah. So I was also actually wanted to come to Chennai. Better luck next time. Cut off, exam mudiyattuda, adukapram cut off. Okay. So yes. So let us continue. The cheer up moment, the warm up, everything is over. Okay. Looking like Dora. I was planned for something and so you also wrote for NEET 2026 and I and the madri than hairstyle also. Lerin Mam become Dora. Nice. Ma'am, pen style change please. So okay. So pen style I won't change. I'll reduce the size. The other one my handwriting is worst. Usually in the physics teachers or handwriting it is very bad, right? Okay. So I wanted to know how many Dora fans here. So yeah, after a few days it will grow and I will again change this hairstyle and everything. So re-NEET ana konja difference irukanola, change venumla. So and the change kaga I have did it. Okay, yes. So those who have joined, you can just subscribe the channel. As I mentioned in the channel, it is not going to disappoint you people. And again, there are a lot of confuse. You can see the likes. Okay, you can see the likes. So it is so unfair, guys. Unfair. Okay, NTA could have given a chance. Okay, and right now I'm just asking you people to give some likes. Adu kuda pata dada. I'm good, Ananya. I'm good. Yes, fan of Lerin. Thank you. Okay. Make us easy to learn. Sure. Okay. We are the Bujis and I am the Dora. Okay. So let us continue. Okay. So let us just give a break for all this kind of chaos. Okay. So right now after this, again after 1 hour, again I will go for some break time. Okay. So on the time we can just chit chat a lot. Okay. So right now let us. Thank you so much. Gopika ma'am will be coming in next 2-3 days. She will come. Okay. No worries. Yellame Lerin Mam army. Yes. More power. So first of all, electric current. What is electric current? Everybody tell me. What is electric current? Electric current, it is nothing but the flow of charges. Correct? So when we are talking about conductors, in the conductors, flow of charges, flow. Okay, so it is actually the flow of nama electrons nama free electrons so in the flow of free electrons so now the thing is like we know the direction of current vandu scalar or vector please let me know quickly neenga Tamila, so in the Tamil kekkumbodhu what you feel, just let me know. Padmanabha, right? So no not Padmanabha, Lovely Karthik, tell me da. Yes. Now tell me what is the direction, what is the scalar or vector? Very good Mahendran, very good YouTube, very good it's gone. Okay, fine. So it is a scalar quantity. So we usually say vector ku direction irukku. So current ku kuda direction irukku. Still we are not considering electric current as a vector. We are considering it as a scalar. Yeah, what is the reason? It is not obeying the vector algebra. Note paniko. It is not obeying the vector algebra. Purinchidada? Give me a heart everybody if you understood the first statement. If you understood the first statement, give me a heart quickly. So first we know current na a scalar quantity da, ana adukku magnitude irukku, direction irukku, still it is not consider it as a vector. Yena adu naughty boy. Okay, so it is not obeying anything, which means nama vector algebra ellame it is not having any value, so it is not obeying it. So adinala we made it into scalar. Some punishment we have given. All the criterias were okay, ana in the criteria he failed. Okay, so adinala we made him to a scalar quantity. So now idoda equation enna if I am talking about average current it is nothing but the charge divided by time da. Okay, if I am talking about instantaneous current, okay, and in a very small, okay, and the time ivlo da irukku, small time da, and the small time la irukra, okay, and the small time la irukra current oda what to say value da dq by dt. Okay, so now Lakshmi in the class வந்து Tamil and English mix இருக்கும்டா. I hope you can understand. Okay, there is no much issues. Mostly I will be speaking in English only, but Tamil also will come in between. Okay, so இப்போ வந்து we understood the instantaneous current வந்து dq by dt. Now my question, I have a question. I into dt, what is going to be? Integral I dt, what is going to be that value? Everybody tell me, what is going to be that value? What is integral I dt? How you will define this? Yes, lots of Karnataka people are there. There is a lot of Andhra Pradesh people are there. Right, lots of Kerala people also there. Ha, Takshin, yeah. Many students, you guys didn't receive the, Google Meet link also, right? Okay, paravalada, next time we are also planning. Not dq, idu vanda delta q. Okay, idu vanda delta q. So now I'm going to ask you some questions. So give me the answer quickly. So ipa vanda I'm just marking charge versus time. Okay, charge versus time. What is the slope? What is the slope of this graph? What is the slope of this graph? Charge versus time graph da. So adoda slope oda value enna? Slope oda value, it is nothing but, very good, it is nothing but namma current da. Okay, this is nothing but current. Purinjadada? So now I'm just going to mark another quantity. Let us say current is there and the time is there. This is how the graph. Okay, what is the area under this graph? What is the area under the curve? Can you just let me know the answer? Can you just let me know the answer? So whenever we are plotting, okay, charge versus time na, adoda slope varadu, it is nothing but current da. Ana vandu when I am plotting current versus time na, adoda area under the curve vara poradhu, it is nothing but namma charge da. Namma total charge da vandu it is. Okay, understood everybody? So, what are the things we have studied? We know what is electric current. Adoda unit enada, can you just let me know in the chat? Unit of current. Okay, first current na, it is nothing but the flow of charges da. Adukku vandu direction irukku. In the direction when I am talking in terms of conductors na, it will be in the opposite direction of flow of electrons da. And idoda unit varadu vandu, it is nothing but, very good Saujanya, very good Mukundan, right? Yes, Takshin. So idoda unit varadu vandu ampere da. And also ipo vandu instantaneous current da. If I'm asking you na, you people will say dq by dt da ma'am adoda equation. Okay, ipo vandu I am plotting this charge versus time graph na, you people will instantly say ma'am slope vandu current da. And other vida, if I am plotting the current versus time graph, what is the area under the curve paakumbodhu, what is going to be the value? What is going to be the value? It is nothing but the charge. Okay, so these are the important facts regarding the electric current. Now we have to study another term, that is nothing but the drift velocity. Now tell me what is drift velocity? We have two types of velocity. First one is thermal velocity, second one is nothing but the thermal velocity and drift velocity. Dora, please go. I don't want you. Okay, so right now we have two types of velocities, thermal velocity and drift velocity. So ipo in the conductor, it is not connected with anything. Okay, simple or conductor. So if I am touching this, okay, I'm just randomly touching. Okay, idla flow of charges irukumla. So should I get this shock or what? Will I get the shock? Yes or no? Yes or no? Tell me, everybody. Everybody, tell me. Will I get a shock? The conductor not connected with anything. Now I'm just touching it. Will I get a shock? No. Yena free electrons ange irukku, and the free electrons will move definitely. Ana vandu adoda average velocity vandu paakumbodhu, we will get this mutai. Correct? Okay, we will be getting 0. So, that is the thermal velocity, which is not going to contribute for the current. Understood, Ada? Understood na? Give me a heart. Okay. So, what I said? So, when we are talking about the conductors, idukulla free electrons irukku, and the free electrons will randomly move. Okay. Zigzag direction it will move. On an average velocity vandu paakumbodhu, it will be coming as 0. Adukapram da we are just going to talk about the drift velocity. Drift velocity na definitely adukulla what is there? We are going to give an external field. Okay. So, ipo in the external external field apply pannitena, if I am giving an external field, what will basically happen? Definitely in the electrons vanda it will start flowing from one point to another point. Adu vanda straight line edu illa. Okay, ipo vanda if you okay, I am giving electric field, they will move in a straight line. Okay, no. Let us say இப்போ வந்து class room ல teacher இருந்தா கூட, I mean teacher was saying okay, just in the line you should go there. Okay, அப்படினால அது வந்து straight line ஆகாது இல்ல, someone will be going like this, another one will be going like this, ஆனா வந்து direction will be correct. Okay, everyone will go out through the door. Understood everybody? Yes or no? So what I was saying, so when we are talking about drift velocity, when we are giving an external field, all the charges will move from one point to another point. The direction will be same. It is not going to be the straight line. It is not going to be the straight line. And idoda range varaporadhu vandu it is going to be 10 to the power minus 3 meter per second, 10 to the power minus 4 meter per second. Anta range la da in the drift velocity irukum. Okay, yes da. Thermal velocity இப்போ வந்து பார்த்தேனா individual electrons க்கு வந்து thermal velocity இருக்கும். Okay, average அதோட average value தான் 0. Okay, இப்போ வந்து நான் வந்து ஒரு electron. Okay, external field எதுவும் இல்ல, எனக்கு வந்து velocity இருக்கு. Okay, எனக்கு வந்து velocity இருக்கு, ஆனா வந்து டோட்டலா okay நம்ம வந்து ஒரு gang தான். Okay, அந்த gang ஓட total strength பார்க்கும்போது தான் 0. Okay, and the average பார்க்கும்போது தான் 0. Individually ஒவ்வொரு எலக்ட்ரானுக்குமே there will be there will be thermal velocity, ஆனா average பார்க்கும்போது it is going to be 0. Understood? Now can you give me a heart everybody quickly? Everybody quickly. And in the drift velocity க்கு வந்து we have an equation E by m into tau. So tell me what is small e, tell me what is capital E, tell me what is m, tell me what is tau. Everybody quickly let me know all these quantities. You know, you people have already studied, right? One can say what is E, one can say capital E, one can say M, one can say what is the tau value. Okay, so actually வந்து இதல வந்து எது new இல்ல, the new one which is actually பேசும்போது இந்த tau தான். நம்ம relaxation torque ஆடா, torque இது torque இல்லடா. Oh my god, நம்ம NEET 2026 முடிஞ்சிருக்கு. இது வந்து ஒரு ரீஸ்டார்ட். ஓகே, செகண்ட் சான்ஸ். அதில் எதுவும் இந்த மாதிரி சொல்லாதடா. ஓகே, டோனா அது வந்து ரிலாக்ஸேஷன் டைம். ரிலாக்ஸேஷன் டைம்னா என்ன? டெஃபினெட்லி இப்போ வந்து நம்ம சிப்ளிங்ஸ் இருக்கும்ல, ஸோ எப்பவுமே we won't fight every second every minute. அதுக்கு வந்து கொஞ்சம் ஃபைட் பண்ணுறதுக்கு கொஞ்சம் டைம் டிலே இருக்கும்ல, ஸோ தட் இஸ் வாட் ரிலாக்ஸேஷன் டைம். ஸோ இப்போ வந்து இந்த ஃப்ரீ எலக்ட்ரான்ஸ் இல்லையாடா, இந்த ஃப்ரீ எலக்ட்ரான்ஸ் will collide each other. ஸோ இந்த successive collision between this, அதுதான் வந்து ஆக்சுவலாக வந்து சொல்லும்போது நம்ம ரிலாக்ஸேஷன் டைம். The time between two successive collisions is known as the relaxation time. Adu vandu it is happening in a very small fraction of time. It is something like 10 to the power minus 14 seconds. Understood? Okay, everybody understood? So this relaxation time is actually 10 to the power minus 14 seconds da. புரிஞ்சுதாடா everybody? Yes or no? Yes or no? And guys, don't forget to subscribe the channel, மறக்காம like பண்ணிக்கோ. And those who have not enrolled in our RE-NEET free crash course na description box la link irukku, enroll pannalam. Okay, yes, sorry Navyasri, sorry Navyasri. Okay, so small e na charge of electron, capital E na electric field, and tau na relaxation time, mass na the mass of electron da. And why this negative sign? When we are talking about drift velocity, we used to mention a negative sign. What this negative sign is indicating? Can you just let me know what is the reason? It is nothing but, ma'am, drift velocity na adu வந்து electron move பண்ற direction இருக்கு logic wise. கரெக்ட்டா? electric field na எப்பவுமே வந்து இந்த electron will be moving to the higher potential இல்ல மேம். so இதோட direction வந்து opposite இருக்கும்ல, so இந்த drift velocity and electric field வந்து opposite directionல தான் இருக்கு. so அதனால we can say that this is going to be representing the direction. Very good Milan, very good, very good. It is actually because of the direction, opposite directionல தான் இருக்கு. That is what they think. Okay, so now another relation which we need to study, the current and drift velocity. Majority ana times la vandu we can expect this question. Okay, majority time la in the equation base panni we can expect a question. So actually vandu you guys have to tell me, Okay, what is the relation connecting current and the velocity? What is that? What is that? It is nothing but N into A into Vd. So now tell me each and every terms. So what is N? What is N? N is nothing but the number density. What is E? Nama charge of electron. What is A? Idu vandu nama what is the area da, and what is Vd? It is nothing but the drift velocity. Very good. You people have told me na, ma'am, yellame marandu pochu ma'am, I don't remember anything. And how you people are giving the answer da? Super good. Very good. Very good. Super. Super. Okay. So ipo vandu I wanted to learn. Okay. I wanted to remember one more quantity. What is this? Everybody tell me, what is this? This is a vector quantity da, because I have represented like this, right? This is the quantity, it is nothing but the current density da. Okay, current density. So on the current density, it is nothing but I divided by A. The current per unit area da, nama current density. Appadina in the equation la, I'm just taking this A over here. So I by A it will come, which is nothing but J, which will be coming as N into E into Vd. Purinjadada everybody? Everybody understood? Yes or no? Please let me know. Give me a heart if you understood. So we have discussed a few equations, drift velocity or equation, current and drift velocity equation, which is very, very important, and nama current density or expression in terms of drift velocity, in terms of nama current. Okay, va. So next one we know nama mobility. Okay, what is mobility? We will represent it as mu, which is nothing but Vd divided by E. The drift velocity per electric field. This is the mobility. Okay. So, actually, the drift velocity sign we can just skip it. That is actually represent. Okay. Now, can we do some questions to make sure in the concepts, in the equations? Okay. Okay, ma'am. Let us go for the question. Without seeing all these equations, we will do it. And the confidence irkada? Everybody? Confidence irka? Let us do it. Ready, ready, give me a fire. If you're ready, give me a fire. Everybody, need more fires? Yes, I'm expecting there will be a lot of fires. So now tell me, when current flows through a conductor, then the order of drift velocity of electrons will be. So order the, check the unit and give me the answer. Check the unit. Okay, wrong answers na definitely punishment irukum. Okay, punishment irukum. So tell me, what is the answer for this question? Check the unit. Everybody. Wow, 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 lots of fires. I know, I told you, na, before I'm seeing these fires, I have expected this. My students will give a lot of fires. So now tell me, answer. I know everyone will give the right answer. Check the unit. It is actually centimeter per second. Hey, centimeter per second da. Centimeter per second da unit. Hey. See, na, the 10 to the power 4 da. It is not possible. And 10 to the power minus 4 meter per second da. Correct? Appadina, just convert into centimeter. Don't say C. Yes, Mahavidya. Right, very good. And Srimukhi, very good. Takshin, very good. Daya, wrong. B and D confuse achu. Okay, so the answer was 10 to the power minus 2 centimeter per second. Adada I have told you, check the unit. Simple question illada. Meter per second answer ungalku theriyum. Okay, appo we need to convert into centimeter per second. Purinjiduchuna, give me a heart. Everybody give me a heart if you understood. Now let us go for the next question. Okay, so now another question. A conductor carries a current of 0.2 ampere, okay, and in 30 seconds, how many electrons will flow through the cross section of the conductor? Okay, so this is the question. How we will be doing it? How many number da we need it? We need N. The number density da we need it. So first one in the number density kadikanumna, I can say that nama Q value it is nothing but Ne da. Correct? So ipa we have to find the total charge. Okay, what is going to be the total charge? Inga current is given. Correct? Current is given. So current na I is equal to I is equal to Q by T da. So I into T will give me this charge. Can you find Q first? Can you find Q first? So I na 0.2 ampere da and time vandu 30 seconds da. So nama charge vandu what is going to be the value? It will become 6 coulomb. Till this understood everybody? When I am asking understood na, please give a heart. So I will get to know you people are getting what I am saying. Very good Navyasri, very good Fatima, very good, super, Hari, very good. So next one we know that nama charge Q is equal to N da. So now the turn is like you can just go for Q divided by E value. Okay. So nama charge which is equal to N da. So Q by E will be giving you N. So 6 divided by 1.6 into 10 to the power minus 19 will give you the answer. Got it everybody? Yes or no? Yes or no? What is the answer you guys are getting? What is the answer? Yes, yes, yes. So what is the answer guys? We will be getting. So now let us go for the next question. The options Adulla, you have to give me the answer directly. Okay. Charge passing through a conductor of cross section A is given by Q is equal to, okay, Q is equal to 3t square minus 5t plus 2. Correct? And what is the question? The time at which the current becomes 0. Very simple. First one, the current you have to find, and on the value you should put it as 0. Then you can find the t value. Appadina, how we will be finding current? It is nothing but dq by dt. You have to differentiate. Before me, I am damn sure you people will be giving me the answer. Let me just challenge you people. Okay, I won't just look back. So I can just do it now. Okay, so what is the answer? 60 minus 5 which is equal to 0. Appadina 60 will be equal to 5, and now from that you can just find the time value. Got it? Got it? Yes or no? Very good Takshin, very good. So simple ana step da, we will be going for 60 which is equal to 5. So t will be equal to 5 by 6. Understood na? Give me a heart everybody. Give me a heart quickly. And I hope everybody is just sitting with a bottle of water and ready with everything. Okay, drink water in between, and we have to give more energy for us. Okay, we need more energy. Okay, time illada. That is what the problem. Okay, so now let us go for the next question. Yes, here we have the next question. Which of the following characteristics of electrons determine the current in a conductor? Simple. You will give the answer like this. Give me the answer like this. Fruit juices meanwhile. Very good. Deepthi, you have attended yesterday's session. I think the same profile photo, if I am not wrong. Very good. It is nothing but the drift velocity. Okay. So we are going for the next question. Yes. So next question. What is the question? The current through a wire depends upon time as like this. Okay. The charge crossed through the cross section of the wire in 10 seconds. Charge we need it. We know how to do it. We have already discussed this equation. I dt will be giving you the charge. Correct? So now I is given. What is I? I is nothing but 2 plus 3t ampere da. And the limit is also given 0 to 10 seconds. Can you find it? Integrate and can you find it? Very good. Integration. Wire back, right? Yes. So now integral 2 plus 3t dt. Okay. Limit on the 0 to 10. So while integrating this, I will be getting 2t plus 3t square divided by 2. Correct? So the limit on the 0 to 10. Here also 0 to 10. Can you give me the answer? So 2 into 10 plus 3 into 100 divided by 2. Give me the answer. Give me the answer. Very good. Already answers were there. Okay, why ma'am? Why you are very slow? Oh my god, after this NEET exam, you people are becoming so fast. Okay, Very good, very good. Now this question I will do first. Let me see. Okay, so give me the equation first, adukapra answer. Okay, so a charged particle having drift velocity 7.5 into 10 to the power minus 4 meter per second in an electric field 3 into 10 to the power minus 10 voltmeter per second has a mobility equation. Let me see who will be writing the answer. VD by E. Correct? So in the VD value one, it is already given in the question, and E value one the oh my god, Kenzo, actually வந்து integrationக்கு எல்லாமே வந்து separate I have did a session da. So in the point in the basic mathematics எல்லாமே வந்து to take those sessions வந்து கொஞ்சம் difficult da. So you can just go back and you can just watch it. Okay, and you should be very good in differentiation integration da, because you can see almost 20%, not 20, 40% of questions in the differentiation integration எல்லாமே இருக்கும். So you have to study. Okay, so yes, oh my god, so fast. Okay, so the answer will be option A. Very good. So now the next question. The number density of free electron in a copper conductor is 8.5 into 10 to the power 28 per meter cube. How does an electron take to drift from one end of the wire 3 meter long? Okay, and to the other end, the cross section of the wire is 2 into 10 to the power minus 6, I guess so. Okay, and it is carrying a current of 3 ampere. Okay, va. So actually we just need to find the time. Correct lada? So adikaga let us just see what are the given datas. Okay, so number density is given. Okay, number density is given. I can't read those values. 8.5 into 10 to the power 28, right? Okay, it is not as clear. Okay, 10 to the power 28, I guess so. Okay, yeah, 10 to the power 28 per meter cube, and electron drift from length one that is given 3 meter, cross section A is given as 2 into 10 to the power minus 6, and current I is given as 3 ampere. Which equation we can use da? Which equation we can use? I is equal to N into A into VD. Right now VD I am rewriting N into A divided by what is drift velocity? It is actually the displacement divided by time. Correct? So in the case la vanda nama conductor oda length divided by time da. So now you can just replace this equation. T will be equal to N into A, sorry, N into E into A, L divided by I it will come. All the values were given in the question. All the values were given in the question. Okay, yes. Give me the answer quickly, everybody. In the point Manas, right? Are you this year you are planning to write the NEET exam? Yes or no? Appadina just study the mathematics da. Like nama basic mathematics lallame vandu konjam confidence irukkanum, illana it is going to be very difficult. Yes. Okay, so now the answer, what is going to be the answer? We will be getting the answer as option A. Very good, Saravana. Very good. Resh, right? Resh, it is very simple da. This is what the equation we have. Okay, I is equal to N into E into A VD. So right now the thing is like enna in the velocity, whether it is drift velocity, whatever be the velocity oda general expression enna, it is nothing but the displacement divided by time. So when I am talking about a conductor, idhula vandu paakumbodhu nama drift velocity la displacement na இந்த electron travel பண்ற displacement da, which means adu vandu in the length of the conductor irukumla. So we will replace it with length divided by time, and we will take T over here and I over here. That's it, done. Okay, this is the only place I feel proud to be a biomath student, ma'am. Very good. Okay, so guys, if you understood this question, give me a heart quickly. Oh my god. Right now then concepts are okay now, you just better start solving questions only. Okay, you can just go for topic wise questions. So through that you will be studying the concept as well. So it will be very helpful for you. Okay, yes. So now let us go for the next question. Adukapram we can go for the next, how many questions left? Okay, one more question. So let us do this question. A current I is equal to 200 milliampere flows in a wire below. What is the magnitude of current density? Current density na, what is the meaning? Current density na I by A. I is already given 200 milliampere. Now it is the turn for area. So which area we will take? That is what the question mark. So எப்பவுமே வந்து the area which is perpendicular to the flow of charges. Okay, அப்படினா the charges is flowing here. So this is the area we should take. In the current வந்து pass பண்ற area. Okay, the current is actually flowing through this area, which means idhula vandu paakumbodhu 10 and 5 it will come. So 5 into 10 da nama what to say in the area vara poradhu. So you can just do 200 divided by 50. Units vandu no need to change da. Okay, units vandu no need to change. Yena vandu it is actually in milliampere centimeter square. Okay, so you can just immediately you can just come to an answer. Because na unit wrong da. So what is the answer? Everybody. Very good, very good. We will be getting option D as the answer. Till this, how many of you are feeling very confident in the equations? In the ellame vanda I could remember properly. I have studied properly. Now it is just I need more question practice from this topic. How many of you are feeling like that? Can you give me a yellow heart if you are feeling like that? Okay, my question is, இப்போ வந்து you are feeling like, ma'am, in the concepts வந்து clear ஆ I mean questions also, basic level question வந்து என்னால பண்ண முடியும். I just need more question practice for it. Then please let me know. Area na very easy Reshma. Actually வந்து எப்பவுமே current pass பண்ற area தான். So இதுல வந்து direction they have given, no. So அந்த current வந்து pass பண்றது இல்லைன்னா charges வந்து flowing like this. அப்படினா it will be this surface area தான் நாம வந்து consider பண்ணனும். Okay வா ரேஷ்மா? Understood? I hope it is clear. Yes or no? Yes or no? Please let me know. Yes, very good, very good, very good. So now let us quickly go for the Ohm's law. Okay, so Ohm's law, can you just let me know what is Ohm's law? Everybody? Ohm's law, what is Ohm's law? What is Ohm's law? It is nothing but V is equal to IR. When this is valid? When this is valid? Tell me. Question practice separate sessions irukumda, so you don't have to worry. Okay, idu vanda concept we will revise. We will do some PYQs. Then we will move on to the next topics. On the madri da we are planned for these sessions. Okay, I hope this is fine. Okay, later on as per your convenience we will switch the plans. No worries. Okay. Yes, when the physical conditions are constant, the potential will be always proportional to the current flowing, and to make the proportionality to equality we are creating or we are introducing a constant, that is what the resistance. So now quickly tell me, this is the graph of two materials A and B. Which one is having the high resistance? Which one is having the high resistance? A or B? Okay, I have plotted this graph. Now my question is, which one, A or B, which one is having the highest resistance? Highest resistance. Tell me, A or B? Highest resistance. Yes. Which is going to be the answer? A. Why it is A? Here I have plotted current versus voltage. Correct? So, if I am plotting like this, V versus I, in the case actually the resistance of B is greater than resistance of A da. Ana in the case resistance of A is more than that of resistance of B. So note panikoda, the slope of voltage versus current graph resistance da. And also if you are finding the slope of I versus V na, adu 1 by resistance. Okay, understood everybody? So simple or mistake usually students used to do, so that is what I have explained. Next idoda or vector form da. What is the vector form of Ohm's law? Do you remember that? What is the vector form of Ohm's law? What is that? It is nothing but our current density term we will be explaining. So J will be equal to sigma into E. Otherwise we can say E divided by rho. So tell me, what is sigma, what is rho? What is sigma, what is rho? Tell me everybody. What is sigma, what is rho? Sigma na conductivity da, rho na adu resistivity da. Both the quantities it is depending upon the material only. Understood? Are you guys getting it? Yes or no? Very good, Devarajan. Very good, Maha. Very good, very good. So this is what the vector form, and in the rho value na resistivity, sigma na, it is nothing but conductivity. Okay, so now we got this expression as well, and from here you can write sigma is equal to 1 by rho as well. So next வந்து quick-ஆ வந்து we are going to study what is resistance. இல்லனா அந்த resistance-ல இருக்கிற things தான் we are going to study டா. So resistance is depending upon the material, the length and the area. So actually வந்து சொல்லும்போது we know that when the length increases, okay, length increases, what will happen? More number of collisions will happen. Okay, and the electrons வந்து it will be very difficult to go through the conductor. அப்படினா resistance வந்து high-ஆ இருக்கும். இப்போ வந்து area increase ஆச்சுனா lot of place. Okay, no collision. Collisions வந்து less ஆகும், resistance வந்து reduce ஆகும். புரிஞ்சுதாடா? நோட் பண்ணிக்கோ. When the length increases, more number of collisions, which means resistance is high, and when the area increases, less number of collision, so the resistance will also reduce. Are you guys getting what I'm saying? Yes or no? Are you guys getting? Okay, so this is another important formula, and now you should study one more equation. For the what to say, nama resistivity kaga we have to study this equation, m divided by n e square tau. Okay, so rho will be equal to like this, sigma will be n e square tau divided by m. Okay, so this equation is very important. Yena idu base panni da we are actually discussing about the temperature dependence. Okay, so nama resistivity is actually m divided by n e square tau da. Okay, tomorrow's live we will be having two live session, 10 o'clock one, another one is at 4 o'clock. Okay, okay, understood. M mass da. Okay, mobility வந்து we will represent it as mu. புரிஞ்சுதாடா? Got it? Yes or no? Yes or no? Yes. Ma'am will be joining in few days da. Actually வந்து ma'amக்கு கொஞ்சம் traveling and everything இருக்கு. So that is what ma'am is missing here for few days. Okay, பரவாயில்ல, once ma'am came back na, definitely we will go for some rocking sessions. So you don't have to worry about it. Continuously some biology classes will also be there. Okay, and this time let me tell you da, in the vati again many students they are getting additional time. So the thing is like we have to concentrate, we have to prepare a little bit more. Okay, so whenever we are getting some time, we will study more. So that will eventually what will happen da, we will be having high competition. Okay, high competition will be there. Understood? Okay, so can we just continue? Are you guys ready? Ready? Yes or no? Yes or no? Yes da. Ma'am, study planner follow panna crack panna mudiyuma? Definitely Gautam, ana vandu follow pannanum. Appadi அந்த ஒரே ஒரு thing மட்டும் தான் இருக்கு. Okay, so இப்போ வந்து you got this equation, rho is equal to m divided by n e square tau. So இப்போ வந்து I'm talking about the conductors. Okay, இப்போ வந்து I'm talking about the conductors. So when I'm talking about conductors, what will basically happen? What will basically happen when the temperature increases? So obviously when I'm talking about temperature increases, okay, when I'm talking about temperature increases, I can see the temperature increases na nama electrons edo oru thing will get it, right? What was that? I forgot. Okay, I forgot about it. Can you just remind me what is actually the thing? Temperature increase aachna electrons ku enna agum? Yes, adoda kinetic energy. I'm assuming like you people are giving the answer. Okay, so it will be getting more kinetic energy. So more kinetic energy na, let us say ipo vandu namakku with the siblings we got a solid reason to fight. Okay, we got a solid reason to fight. So on the fight வந்து அவ்ளோ strong இருக்கும்ல. So I can say that when the temperature increases, kinetic energy increases, in the relaxation time இல்லையாடா அது வந்து reduce ஆகும். Relaxation time will reduce. What is the meaning of that? நம்ம time between two successive collision வந்து reduce ஆச்சு. அப்படினா what will happen to resistivity? Tell me, what will happen to resistivity? Tell me everybody tell me. Of course, you have to practice every day, question practice. So 400, which means if you are, it is not just in biology. Biology la vandu 300 kadichirukke. Physics, chemistry da rest of the 100 na adu vandu konjam kashta irukumda. If you are just getting some more marks in physics and chemistry, next few days la biology vandu pick up pannalam, and chemistry, physics vandu you need more practice. So it will be sorted. Yes. So in the value வந்து decrease ஆச்சுனா நம்ம resistivity வந்து increase ஆகும். புரிஞ்சுதாடா? So right now in the conductors partல I can say that if I am plotting the resistance with versus the what to say நம்ம temperature na அதோட graph வந்து இப்படி தான் இருக்க போறோம். Okay va? When temperature increases, kinetic energy increases, what will happen? Definitely in the what to say relaxation time when the reduce agum, resistivity will increase. And for alloys like nichrome and all, what will happen? This variation in the resistivity illana ipo vandu high temperature range irundha kuda there won't be much kind of difference. Okay, it will be temperature adhigama irundhal in the resistivity la irukra change vandu kammiya da irukum. So for alloys actually this is how the graph. Okay, the temperature range வந்து பாக்கும்போது அந்த டைம்ல இருக்கிற resistance change வந்து it is less தான். அதனால தான் for making resistors we are actually using this alloys. Understood? So right now ஒரே ஒரு equation base பண்ணி தான் we were discussing all these things. Okay va? So right now I have talked about the conductors. So conductors la பேசும்போது இந்த m value, n value, e square எல்லாமே வந்து constant இருக்கும். Next வந்து நம்ம relaxation time தான். When temperature increases, kinetic energy will also increase and the relaxation time will decrease. அதனால what will happen da? நம்ம resistivity will increase. Understood? Got it? Now for alloys what will happen? In the range வந்து இந்த temperature அதிகமானாலும் அதோட ஒரு response for resistivity வந்து கம்மி தான். அதனால தான் we are using this for the making of resistors. Got it everybody? Yes or no? And for the semiconductors what will happen? For semiconductors in the equation la பார்த்தேனா we know m divided by n e square tau. So semiconductors எல்லாமே வந்து நம்ம charge carriers ஓட value வந்து when we are comparing with conductors it is very less. Correct? Yes. Okay, so இப்போ வந்து rho which is equal to m divided by n e square tau da. So இதுல வந்து பார்த்தேனா when we are talking about semiconductors இந்த n value வந்து கம்மி தான். Okay, the number of charge carriers வந்து less தான். Okay, and adinala I can say it is not, the relaxation time is not having much influence. Ana vanda when temperature increases, this is for the semiconductors. When temperature increases, what will happen basically? When temperature increases, definitely the number of charge carriers increases. This is the next chapter we are going to study. Okay va? So temperature increases, number of charge carriers increases. Appadina what will happen? In the value increase achu, what will happen to resistivity? Tell me everybody tell me. Yes, what will happen? What will happen? Definitely when the n increase aachuna resistivity will decrease. So these are the important points that you guys have to study. And another one, the general expression. I hope everyone has written this. Semiconductor, alloys as well as the conductors. Okay, very good Resh, very good Manas, very good I can't read. Love learning, very good Dark Knight. Yes. So now we got this. Okay, so next வந்து இதோட ஒரு general equation வந்து you have to study da. Rho is equal to rho naught into 1 plus alpha into delta t. For the resistance also you just need to replace this. Okay, you just need to replace rho with r. This is what you need to do. Okay, so now what is r naught? Illana, what is rho naught? Can you just tell me what is that? Can you just tell me what is that? What is r naught? அது வந்து நம்ம reference temperature. Okay, reference temperature la irukra resistance da R0 and RT na enna, when we are increasing the temperature, what is the change, or let's say what is the at present and the time la irukra resistance oda value. Understood? Yes or no? Yes or no? Can you please let me know? Alloys வந்து it is having a very least response to the temperature. Even if you are giving a huge temperature also, resistance change ஆகிறது வந்து it is going to be very less. புரிஞ்சுதாடா தீப்தி? Got it? Okay, simple da irukke. So when we are talking about alloys, the response to the temperature vandu kammi da. It is not going to be on the quick reaction idulla like conductors and all, but definitely there is a small change, and the change nala da and the graph vandu apdiye irukku. Crystal clear, very good. So இப்போ வந்து இந்த equation la R0 na it is nothing but the resistance at the reference temperature, and capital R na it is nothing but the temperature at resistance at particular temperature. Alpha na coefficient of this thing da. So and the alpha value or the positive negative values will be coming. So alpha value will be positive 4. Mansi, okay Mansi. Okay, so what is the alpha value? For conductors it will be positive, for semiconductors it will be negative. Now quickly tell me, if I am connecting resistance in series, I have two resistors R1 and R2. Tell me, if I am connecting in series, what is going to be the value? What is going to be the value? It is nothing but R1 plus R2. If it is parallel, what will happen? I know 1 by Rp, which is equal to 1 by R1 plus 1 by R2. Illana, I can write Rp, which is equal to R1 R2 divided by R1 plus R2. If I have n identical, okay, n identical resistors, okay, I have n identical resistors. So tell me da, in series la, what is going to be the equivalent resistance? It is going to be nr, and in parallel it will be coming as R by N. Understood everybody? Yes or no? Give me a quick response if you understood. Quick response everybody. Everybody give me a quick response. So can we go for the question practice? Ready na? Give me a fire. Question practice. So we have studied a lot. Now it is the time for break. We should do some questions. Tell me. Ready now? Give me a fire. Yes, very good. So now let us go for the question. I'm not making any delay. Let us go for the first question. So the resistivity of a potentiometer wire is, okay, resistivity is given 40 into 10 to the power minus 8. Okay, and its area of cross section is also given 8 into 10 to the power minus 6. Current is given 0.2 ampere. What is the potential gradient? What is this potential gradient? Now on the study pannirukra oru topic da, potential gradient. Gradient na what we should do da? Eppovume I used to mention gradient na we should do something. What is that something? Tell me everybody. What is that something? Definitely we know that edachu oru quantity oda gradient ketena, what we should do? And the quantity divided by length. Idha vandu we should find it. Okay, so now vandu how we will be finding V by L. Okay va? So adha vandu question. How we can just do da? How we can just do? So let me just go for, let me take another sheet. Will be fine, right? Very good. So now V will be equal to I into R da. So now R oda value vandu we know that rho into L by A da. Correct? So now I am taking V by L. Appadina what I will be getting? I into rho divided by A. So this is what I wanted to find. Are you guys getting it? Yes or no? Yes or no? Yes or no? Polar bear mode started. Of course, love learning. Yes, I'm feeling so. That's right. And no one will come today to the studio, so they won't complain. Understood? Yes or no? Yes or no? Tell me quickly. Everybody. Tell me quickly. Have you understood how this equation comes? How this equation comes? Just we are putting the value of resistance. Resistance na rho into L by A. take this L over here. So inga vandu V already irukke. L we will be just taking here. Then I rho divided by A it will come. So now tell me what is going to be the answer. All the values are there. All the values are there. Yes, 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 yes. Kirtana fast enakku vandu I can go even more faster. Ana vandu again few students irukida avungalku vandu I cannot do that fast. Okay, so please, please, please. Okay, konjam kuda time ku appuram and warm up time ellame mudinjadukku appuram we can just go. Okay Kirtana, yes, very good, very good. We will be getting 10 to the power minus 2. Very good. So now we are moving on to the next question. Again simple ana or question da. Two resistors are joined in parallel. Adoda resistance is given. Okay, so R1 R2 divided by R1 plus R2. Correct? If I am connecting two resistors na idudha vandu equation. Parallel connection ku vandu idudha vandu equation. That is coming as 6 by 8. Correct? 6 by 8 da. The resistance of the wire is broken and the effective resistance become 2 ohm. Okay, so then the resistance in the ohm of the wire, okay, resistance in ohm of the wire that got broken was. So idilirundha we understood any one R1 or R2 we understood it is 2 ohm. Okay, yena broken and right now we got one adoda resistance da 2 ohm. Correct? Broken, which means definitely we will be get to know one is having a resistance 2. Next step yenada, just substitute this value. So 2 into R2 divided by 2 plus R2, which is equal to 6 by 8. Can you find the answer? Can you find the answer? Yes or no? Yes or no? Yes or no? What is the answer? What is the answer? Eva, check it again. Yes, Soumya. Yes, Milan. Very good, very good, very good. Yes, yes. We will be getting 6 by 5 as the answer for this one. Okay. The other resistance will be coming as 6 by 5. Okay. Yes, very good. C da vandu correct ana option. Now, let us go for the another question. Okay, so we have two wires of equal length and equal diameter and having resistivities rho 1 and rho 2 are connected in series. The equivalent resistivity of the combination. Idudha vandu ketirike. So simple sonnitena we know the equation. Yenada equation? R vandu if it is in series it will be R1 plus R2. Am I right or wrong? Yes or no? Yes or no? Are you guys getting it? So appadina A. Everybody is getting the answer. Okay, so now R1 plus R2. Now what we should do? We need to rewrite R1 and we need to rewrite R2 in terms of resistivity. So we know the expression. R is equal to rho into L by A da. Correct? So in the question they have given diameter equal da, length equal da, ஒரே ஒரு quantity மட்டும் தான் சேஞ்ச் ஆயிருக்கு, அது வந்து resistivity தான். So now I can say rho 1 into L by A. R1 will be rho 1 into L by A plus R2 into L by A. Am I right or wrong? Everybody understood till this now? Give me a thumbs up or heart, anything. Please share. Please give me a heart. Everybody. So what I was saying, so we have rho 1, we have rho 2. So R1 ku vandu I have replaced the resistivity as rho 1. Rest of the values vandu constant da. So I am taking L and A. Okay. Now I am getting rho 1 L by A plus rho 2 L by A. Okay. So now the left hand side la in the equivalent resistance la definitely nama resistivity ku vandu or equivalent value irukum. What is going to be the length? We connected in series. Okay, so in the resistance oda in the resistor oda length vandu L da, in the resistor oda length vandu L da. Appadina when I am connecting this two, what is the total length? What is going to be the total length? Tell me quickly, what is going to be the total length? Very good, Ishwari, right? Yes, it is going to be 2L. So 2L area vandu it is not going to change. So L by A, L by A, L by A. So the rho equivalent will be coming as rho 1 plus rho 2 divided by 2. If you guys understood this explanation, give me a quick red heart. Everybody, I'm specific about it. You guys have to give me red heart. No other option. Give me red heart, please. Everybody. Yes, 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 yes. Very good, very good, very good. So now again we are moving on to the next question. Yes, so actually you know what, I didn't even prepare anything because you students have told me, ma'am, I mean I couldn't remember, ma'am. So I was also want to test myself, okay, whether I can remember everything or what. Then only I can just I can give advices to you, na. So I think till this point I too remember everything, okay. So that is what the thing. It's minus in the first option, huh? Minus now we will change to plus. And the question error da. Forget it. Okay. No other options, right? Yeah. So that's correct pannalada. Options ellame wrong varundhuchu, we will correct the option. Fine, Saravana. Okay. So yes. So now we are going for the another question. 3 resistors irukada, 5 ohm, 5 ohm, 6 ohm, connected as shown in the figure. The point S divided into resistance 6 ohm into 2 equal halves, and the resistance is also becoming 3 ohm, 3 ohm. Appadina, what is the resistance between the point P and S? This is the question. So appadina, let me just tell you. So in the split this is what 3 ohm, this is what 3 ohm. So let me just redraw this diagram. Okay, this is our S. Okay, so we have 3 ohm in the resistance one. I'm just splitting. Okay, this is what the another 3 ohm. Then again we have another 5 ohm, and here we have the P, and here we have the another 5 ohm. Now circuit is done. Everybody understood the circuit? Circuit? Yes, yes, Manju, tell them. Guys, like the session. And also don't forget to enroll the free NEET crash course, okay? Free the 0 rupees the, okay? And you're going to get a lot of features. And the features, I think on my channel, they have uploaded the complete details. Explain video. Okay, va? So right now what will happen da? In the 5 ohm and in the 3 ohm the series la irukke, and this is also in series. So 5 plus 3 8 ohm da. So I'll be getting, okay, idudha nama P, idudha nama S. So I will be getting the circuit like this. This is 5 plus 3, this is again 5 plus 3. So now this 2 8 ohms parallel da. Appadina, what is the equivalent? Yes, already you people are giving the answer. Very good. So the answer will be coming as 4 ohm da. Very good, everybody. So can we go for the another question? Ready now? Give me a fire quickly give me a fire because my energy is drained. Okay, give me some fire, everybody. Very good. Yes, I can see someone is asking some doubt. I got wrong. Paravalada. Okay, I missed someone's doubt. You can just ask again. Okay, yes. So now let us go for the another question. Again, simple resistance related. You are given 2 resistance R1 and R2. By using them singly in series and in parallel, you can obtain the resistance of 1.5, 2, 6 ohm, 8 ohm, the value of R1 and R2. So when you are just connecting these 2 resistors in different P, should we take it at a junction? That will also fine. And the junction on the P dana. Okay. So yes. So இப்போ வந்து பாக்கும்போது you can just see that. Okay, you can just see that in the 2 resistance வந்து we don't know R1 and R2 da. In the R1 and R2 use பண்ணி we will be going different combinations, and finally we got some different resistance. We know that when we are connecting 2 resistance and we will be getting the maximum when it is in series. Am I right or wrong? Yes or no? Minimum when we will be connecting in parallel. So appadina maximum R1 plus R2. What is the maximum value? 8 ohm. Yes. Okay. So minimum value na R1 R2 divided by R1 plus R2. Yeah, now we need to connect it in parallel, right? 1.5, which means 3 by 2. Understood till this, everybody? Yes or no? Please let me know. Are you guys understood till this? இப்போ வந்து different combinations try பண்ணிருக்கேன். We know that whatever be the condition, it will be maximum. The resistance will be maximum when it is connected in series, minimum when it is connected in parallel. So I have written both the equations. Okay guys, மறக்காம like பண்ணிக்கோடா. And now I'm replacing it here. ஏனா R1 plus R2 வந்து I know it is 8 ohm da. So R1, R2, I will be get it as 3 by 2 into R1, R2 na 8 da. And the 8 வந்து I will be taking over here. So what I will be getting? I'll be getting 12. Okay. So now you have two relations. Okay. This is what the first one. This is what the second one. Which means multiply பண்ணும்போது you should get 8 ohm. Oh sorry. Add பண்ணும்போது you should get 8 ohm. Multiply பண்ணும்போது you should get 12. So what is the answer? Guys, smash the like button. So tell me which is going to be the answer. Which is going to be the combination? While you are adding, you should get the, what to say, that 8 ohm thing. Okay. And multiplying, you should get 12. Very good, very good. 6 and 2 da nama answer varaporadhu. Can we go for the next question? Ready na? Give me a fire. Very good, very good, very good. Who said you people have forgot everything? I wanted to see those who have mentioned. All question you are giving the right answers in a very small time you people are giving. So what is the point of saying maranditte ma'am? Okay. So in the question we should find the equivalent resistance between A and B. Okay va? And over a resistance order value வந்து 1 ohm da. Okay va? Okay, shall we do it? Ready? Ready, ready, ready. So I hope you will be giving the answer quickly. Okay. So let me see anyway. So இப்போ வந்து இந்த questionல I just wanted to know what type of connection it is. எனக்கே புரியல why you are giving different wires. Okay. Why you are connecting like this? Why you are making it as complicated? Okay. So let us see. So இப்போ வந்து பார்த்தேனா I'm just going to give some numbers. Okay, inga vanda I'm giving 1. Inga vanda I'm giving 2. Okay. Now, can you just tell me, ipo vanda in the point la irukra potential da I'm just mentioning it as 1. In the point la irukra potential da I'm mentioning it as 2. Appadina tell me da, in the point la what is going to be the potential? Yena vanda I have connected it with the wire, right? அப்படினா இந்த potential இந்த பாயிண்ட்ல இருக்கிற potential தான் இந்த பாயிண்ட்ல கூட வர போறோம். Got it everybody? அப்படினா இது வந்து again இதோட potential வந்து same 1 தான். Can you just give me what is going to be the potential at this point? Can you give me the answer? இந்த பாயிண்ட்ல இருக்கிற potential இந்த பாயிண்ட்ல இருக்கிற potential மேம் எனக்கு தெரியும். I will tell. Tell me da. What is going to be the potential? Very good. ஏனா இது வந்து இப்படி தான் கனெக்ட் பண்ணிருக்கேன்ல. So இது வந்து 2 தான். So now let me just say I'm just going for this resistor 1 ohm தானா. So இதோட இந்த பாயிண்ட்ல இருக்கிற potential na 1 தான். இந்த பாயிண்ட்ல இருக்கிற potential na 2 தான். Till this understood everybody? Give me a red heart. Till this understood na? Give me a red heart quickly. Give me a red heart quickly. Till this understood. Give me a red heart. So ipo vanda I just took this resistance. Okay. 1 ohm da value. So adoda inta point la irukra potential 1 da. Inta point la irukra potential 2 da. Now I'm just thinking about this resistor. Yethachu similarity irukka? ஏனா அந்த ரெசிஸ்டரோட two sides two ends பார்த்தேனா same 1 and 2 the potential வர போறோம். So can I just replace அந்த ஒரு ரெசிஸ்டர் இல்லடா. This is 1, this is again 2. Can I just say this resistor is this one? Can I say this? Yes or no? Give me yes or no. Specifically you should tell me yes or no. Everybody tell me. So what I said, in the resistance order, I mean 2 ends பார்க்கும்போது one side la potential 1 தான், another side la 2 தான். இங்க கூட பார்க்கும்போது I can see this is 1, this is 2. So அப்ப வந்து potential across in the two resistors வந்து same தான். அப்படினா அது வந்து parallel தான். Got it everybody? Yes or no? Got it everybody? Very good. So அப்படினா now I'm going to think about this one. So இந்த ஒரு ரெசிஸ்டரை பார்க்கும்போது one side வந்து potential ஏதா, another sideல 1 தான். So இதுதான் வந்து நம்ம 1. Okay. அப்படினா I will draw like this. This is again 1 ohm. Now I'm just thinking about this one. இதோட one side வந்து B தான், another side வந்து 2 தான். So அப்படினா இந்த ரெசிஸ்டர் வந்து இப்படி தான் varaporom. Now you understood how we made the circuit. Are you confident about this right now? So inga oru 1 ohm irukke, inga oru 1 ohm irukke. It is actually coming as, okay, it is actually, so I think I missed one resistor da. 3 resistors irukkella. This is the one, 1 2, this is again 1 2, and here again one more is there da. Sorry. Okay, this is again 3 resistors irukku, potentials across them is same. Are you guys getting it? Feeling confident? Please let me know. Should I need to repeat this? If I need to repeat, na, give me R, R, R. If more R's are coming, I will repeat. In the circuit kadachena, you will do it simply. And on the circuit da complicate arke. Guys, smash the like button. Yes. Thank you, Manju. Yes, yes, yes. Okay, okay. Yes, 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 yes. See. Done, done, done. Okay. So, ipa vandena, we will be seeing that in the resistor, adoda potential across all these 3 resistors the same da. Appadina we should understand potential across the resistors same, which means adu vandu connect panni irukkiradhu parallel connection da. So, on the parallel connection da I have made it here. Now the thing is like எனக்கு வந்து one more resistor இருக்கு, அது வந்து I kept it like this. இங்க ஒரு resistor இருக்கு, அதோட one terminal வந்து 2 தான், so I will be connecting it with 2. அப்படினா now இது வந்து same resistors, இதோட equivalent resistance வர போறது 1/3 தான். So இப்போ வந்து நம்ம resistance வந்து இப்படி தான் நம்ம circuit. This is 1/3, this is 1 and this is 1. So 2 plus 1/3 it will come. So I'll be getting 7/3 as the answer. Hence option C will be the right answer. Yes, I can see. Yes, yes, yes. So now can we go for the next question? Yes or no? Ready? Yes or no? Option C da, 7/3. Okay, so now let us go for the another question. I hope everybody is ready. Okay, yes. So in between I need to go to take some water, okay, because I'm feeling so drained. Okay, polar region, we need to drink more water. So now in the figure shown the total resistance of between A and B the question. In the circuit paakumbodhu you will feel like enna ma'am enna circuit edu and madri you will ask, but it is a very simple circuit. So first la vande in the 2 resistors vande we can remove. Why? Can you just give me the reason? And the 1 ohm vande I have removed, quickly I have removed. Why? What is the reason? What is the reason? What is the reason? Tell me. Wheat bridge. Adu enna wheat bridge? Adu vandu pudusa irukke. So now tell me why that 1 ohm is removed. Yena adula vandu connection illa, current will not go through it. So we can just simply remove. Okay. So now the circuit becomes so simple. Now if I'm just checking on it, idu vandu 2 ohm da, 1 ohm series la da irukke. This is again 2 ohm, 1 plus 1. This is again 2 ohm. This is again 2 ohm. So let me just redraw this. Let me just read. இன்னைக்கு வந்து we won't do அவ்வளோ டஃப்பான questions வந்து we are not going to do da. We will just revise the concept. அந்த கான்செப்ட்ல கொஞ்சம் கூட clarity கிடைக்கிறதுக்கு we will do some PYQs. இதெல்லாமே வந்து PYQs தான். Okay, so இன்னைக்கு வந்து அப்படிதான் we have planned. So if you need some session like அவ்வளோ டஃப்பான questions வந்து we need it ma'am, and அப்படினா இந்த comment boxல you just mentioned da. So we will quickly go for that session. Okay, we have planned after few days, but definitely if your requirement is that na அந்த comment boxல போட்டுக்கோ. And those you guys are want, okay, எனக்கும் இந்த மாதிரி ஒரு session வேணும்னா you also just comment there. So when the comment number of comments increases na, definitely I will go for that. Okay, புரிஞ்சுதா? Very good Manju. No current, that is what the reason. So அப்படினா இங்க தான் நம்ம A இருக்கு. Okay, so இது வந்து 2 ohm da. This is nothing but நம்ம 8 ohm da. This is nothing but our 2 ohm da. And இது வந்து 1 ohm it becomes 2 ohm, and here it becomes 8 ohm. Here it becomes again 2 ohm, and here again we have 2 ohm. Here again we have 4 ohm, and we have this 2 ohm here. So now again this becomes a very simple question. Okay, so now 2 4 2 will be in series, correct? இது வந்து சீரீஸ்ல தான் இருக்கு. அப்படினா இதோட equivalent resistance வர போறது வந்து it is nothing but I'm replacing with a single one now. It will be coming as 8 ohm. Till this understood everybody? Give me a thumbs up. Give me a thumbs up. Yes, exactly Lakshmi, that is what I have planned. ஏனா வந்து 9-10 days ஆச்சுல, so you will definitely, even we say that அதெல்லாமே வந்து அங்கே இருக்கும், definitely we will have some sort of equations and everything we will forget. So that is why I felt like we can just go for a quick revision, adukapram question practice. So ipo vandu in the question practice ellame பண்ணும்போது you will feel like more confidence. Okay, adukapram let us plan for some tough questions and the series e plan பண்ணலாம். So மறக்காம இந்த செஷனுக்கு அப்புறம் you guys should give me a comment regarding this. Okay, முதல்ல easy questions முடிச்சு we will get some confidence and then we will move on to the tough ones. Yes, exactly, yes. So ipo vandu idu vandu 8 ohm ஆச்சு. Now you can see idu vandu ஒரு 8 ohm da, this is again another 8 ohm, idu vandu 2 vandu parallel da, correct? This two resistors vandu parallel da. What is the equivalent resistance? Tough questions ipo vena. Okay, illada இன்னைக்கு வந்து I didn't add much tough questions. Yeah, see, I mean in the resistor series la வந்து I kept some tough questions and வந்து இன்னைக்கு I'm not going to do. Okay, let us just take some relaxed class today. Yes, very good. So now again I'm just going to replace இதுதான் வந்து நம்ம 2 ohm 8 ohm 2 ohm. Okay, and again 2 ohm, here நம்ம வந்து 4 ohm, here again 2 ohm. So again what will happen? 2 ohm 4 ohm 2 ohm. So this is again 8 ohm. In the 8 ohm and this 8 ohm will be parallel, so it will become 4. So 4, 2, 2 will be coming in series. What is the answer? What is the answer? Quickly let me know. Quickly let me know da. Everybody give me the answer. Got the answer? Very good. We will be getting 8 ohm as the answer. Idu vandu replace agum. This will become 4. 4 plus 2 plus 2, it will be coming as 8. Now let us go for the next question. Okay, actually vandu energy vandu reduce agudha. I need some kind of what to say, nama energy kaga what you guys will do da? Energy. Repeat. Okay Lakshmi, I will do. So okay, inge irukelle. So first on in the step you understood, right? 1 ohm will be removed. Got it? Okay, just listen. So those who are feeling difficult in this now, please let me know. Okay, others just observe the previous questions we have done. So idu vandu 2 minutes la I'm going to finish. Okay, so guys give me some kind of awareness, okay, whether you guys are getting each and every step. Okay, so understood na, give me red heart, then I'll get to know. Okay, so ipo vandu 1 ohm irukke, adu vandu cancel aachu. So அப்படினா இங்க ஒரு 2 ohm இருக்கு, this is again 4 ohm, this is again 2 ohm. So இது வந்து சீரிஸ்ல தான் இருக்க போறோம். Okay, இது வந்து சீரிஸ்ல தான் இருக்க போறோம். அப்படினா what is going to be the value? 2 plus 4 plus 2. அப்படினா அது வந்து 8 ohm தான். Correcta? So now what I can do? I can replace this whole. Okay, I can just replace this whole with a simple resistance that is 8 ohm. Understood till? Understood? Equivalent resistance ennava? Ennada in the question allame varudhu? Guys, yarukavadu, can you just give me the answer for him? What is this equivalent resistance? Okay, adu vandu series la daanda irukke. 2 2 2, 1 plus 1 2 plus 4 again 6 plus 1 plus 1, it is coming as 8. Okay, so ipo vanda you got in the 8 ohm and in the 8 ohm vanda parallel da irukke. So now you can just replace this also and this will become 4 ohm. Correct? So now again 1 plus 1 plus 4 plus 1 plus 1, it will become again 8 ohm. I'm just going to replace. So this will also become 8 ohm. So 8 ohm will be in parallel. So we will be getting this as again 4 ohm. Just ignore the rest of the thing. Now you got the circuit like this. So inga oru 2 ohm irukke, inga oru 4 ohm irukke, and here again you have a 2 ohm. So this is what terminal A, this is what terminal B. So 2 plus 4 plus 2, you will be getting 8. Okay, So now we will be going for the next question. Innum simple ana oru question da. Okay. Hari. Okay. So now, okay. So whenever you people are asking which chapter it is and all, it is making me, okay, I hope you are not a 12th grade student. Okay, correct, Hari? Yes. So now, tell me, in the question, what is going to be the answer? In the below circuit, the battery even has a voltage, okay? So the EMF one, it is nothing but 12 volt, correct? So now, it is connected with a resistance and 0 internal resistance. Another it is nothing but 2 volt, okay? So now, if the galvanometer G reads 0, find the value of resistance X in O. This is the question. So, first what we should find, we need to find in the X value da find pannanum. Correct? So, adukkaga there are some hints given in the question. Okay, first galvanometer reads 0. Appadina, what is the meaning? The potential difference is 0 da. Appadina, the potential across this point and this point is same da. Correct? So let us say there is a current I is flowing through here. Okay, I is flowing through here. So now what will happen? In the potential difference is the same. So adinala here there will be same current will go. Okay, so now the thing is like if I'm just looking at the diagram, first I wanted to find what is this I. What is the current flowing through this loop? In the loop, what is going to be the current flowing? So, in the current flowing equation, the EMF illana voltage divided by total resistance. Correct? Appadina, I will say I is nothing but the voltage na 12 divided by 500 plus X. Till this understood, everybody? Everybody tell me. Till this understood? Okay. Fine. Okay, so now I'm just considering this loop. So if I need to find the current, I know that the current, if I need to find, it is nothing but the voltage, the potential difference divided by the total resistance. So if I total resistance 500 ohm X ohm the potential difference E1 which is given in the question 12 divided by 500 plus X. Got it, everybody? Yes or no? Yes or no? Are you guys getting it? Okay. So, if IZ in the potential difference and in the potential difference one the same. Which means how I'll be finding the potential difference across this? What is the equation for potential difference? I is equal to V is equal to IR. Correct? So, in the case I want I da, R na X da. What is the V value? What is the V value? Same da. Yena galvanometer reads 0. Correct? So, potential difference should be same. Adula vandu current pass pannala. Okay, va? So, appadina definitely. In 2 hours we will finish da. We will finish current electricity as soon as possible. Adikapram we will start semiconductors. Okay? No. Till 8:30. Max to max 8:30. Adikapram it is not going to go. Okay? Now I got it. So, இப்போ வந்து பார்த்தேனா I will be get it as 2 by x. So now I க்கு வந்து I got two equations. This is 1, this is 2. Till this understood? Till this understood? Till this understood? Yes or no? இப்போ break 1.5 hours ஆச்சுல. It is it a break time? No na. No, it is not a cell topic revision irukku. No worries. அது இருக்கும்டா. Okay, let me finish this. So yes, so now you can just equate 1 is equal to 2. So 12 divided by 500 plus x will be equal to 2 by x. Can you just find me the answer for this one? Can you just let me know what is going to be the answer? I hated these questions. Repeat, simpler da irukenda. So first of all, நம்ம வந்து current ஓட equation தான் find பண்ண போறோம். Current ஓட equation பார்க்கும்போது we know that it is V by R தான். okay so inga vanga paakumbodhu the total resistance na adula vanda 500 irukke x irukke so appadina 500 plus x it will come okay va so now I have written that, let it be there, I am not considering about it. Now in the question they have mentioned in the G galvanometer reads as 0. Appadina idhula vanda there is no current flow, which means the potential across these 2 points vanda it is same. Appadina we know inga vanda 2 na inga irukra potential kuda 2 ah irukanum. What is the equation for potential? According to Ohm's law we know idu vanda I into R da, correct? So now I will be substituting that. In the case la what is R? X da, I will substitute. In the case la what is V? Adu vanda 2 da, I have substituted. Now I have written in the X vanda I took it this side, so I got I value. So now I am just equating both the sides. Yana inga kuda I oda equation da, here also we have the I oda equation. So now you will be getting the equivalent value. Understood? Got it everybody? Yes or no? Adukku vandu definitely we should use the loop rule da. Okay, definitely there will be some current will be flowing there, we will be using loop rule. Adha vandu next we are going to do. Live will be till 8:30 hardly. Okay, so anybody needs the break time? Anybody needs the break time? But if I am giving break now, you people won't come back, you people will relax for some time. I don't want that to happen. I don't want that to happen. Why you are why I'm not ignoring your message. I couldn't see it, that's why. No break. Yes, okay, let us go for it. So what is the answer for this question? Quickly let me know. What is the answer for this question? What is the x value? Idhula vandu ore oru unknown da irukke x value. What is that value? Just check the live sessions da, you can see all the live sessions. Yes, very good, we will be getting 100 as the answer. So now I'm skipping the rest of the questions and I'm going for the another concept na simplana or concept. What is the simplana concept da? Nama KVL and KCL rule. Okay, tell me what is the junction rule? What is the junction rule? Quickly tell me, what is the junction rule? What is the junction rule? The sum of the current, correct? The sum of the current vanda, what is the value for it? Guys, 1 second da. Okay, so tell me what is KCL and KVL? If I am doing something, you should also be packed with something. Yes, and everybody has enrolled in this one, right? Nama RE-NEET crash course. So description box le paatha podumda, you will be getting the link of that one. Yes. Sorry guys, sorry. Yes, so ipo vandu paathena we know very good, should I explain that? Okay, KCL na junction rule da, which means the current entering into the junction will be equal to the current leaving at the junction. The sum of the current vanda 0. Okay, and KVL na it is actually, if you are considering a closed loop, adukulla irukra potential difference oda sum vanda 0 irukum, which means it is based on the conservation of energy. Na vanda edachuri energy tandena everyone should utilize it, there is no wastage. Okay, I'm giving you 50, you have to utilize the 50. Got it? So adha vanda adoda principle. Now straight vanda we are going for the actually I am just planning the Mano, right? Okay, so actually the long marathon I am just planning in the what to say, either the Sunday or Monday I will go for the long marathon. Okay, maybe in the next few days I will go for it. Yena we also just planning something, so in the planning vanda proper schedule panni we should make a proper plan for you people, right? So adanala da still the discussion is going on and we will let you know. Okay, so now let us go for the question da. So first question. Okay, yes. Yes, so yes. 10 o'clock ku one session irukida and also one session at 4 o'clock. Physics ku vandu 4 o'clock irukida, morning vandu chemistry da. No chemistry today. Nalekita. Okay. Ma'am, one question, G no deflection na, it is 0. Potential difference vandu 0 aganum. Okay. What is the use of the batch na? You will be getting, in addition to these classes, you will be getting 24/7 Insta doubt solving app. Okay, you can ask the questions at any time, you will get the solution. And also, in the class, if you are watching in the app na, and the app you will be having an option to ask the doubts lively. So you have mentioned, oh, why ma'am, why you are not considering my messages and all. So there will be an AI which will be considering all your messages, everything, so you can ask your doubts. And on the AI actually based on NCERT da. Okay, so you will get the answer based on NCERT, so you don't need to worry about anything. If Google la check pannina kuda, you will be getting different answers from different sources, right? So idu appadi edum thevai illada. So it is based on NCERT mattunda, so you will get the proper answer for it. And also a full length test series irukke. Every 5 days we will be uploading 6-7 test series. So, and adukapra adoda leader board kuda available irukum. So basically vandu sollumbodhu you will be having a healthy competition between you people. Okay, ena vandu anneki I mean those students who have appeared for the exam, avangaloda result vandu it will be coming together. So ipo vandu yes, my position is 25, next time vandu I wanted to become first, and the healthy competition kuda. Okay. Yes ma'am, yes, notes vandu class mudinjadukku appuram you will get, app la kuda you will get it da, no worries on it. Okay, so tell me, what is the answer? What is the answer? Yes, Sunday also we will have class. So cut clean, okay, I don't know. D official. Okay, so you can just check in the description box. The description box la first link click panna podum, you will be going straight to the app. Okay. Yes guys, like the smash button da, and the button ke edo problem edu illada, please. Okay, so now in the answer vandu C wrong, don't say C. C is wrong. Hello ma'am, I'm back. Where you went, Navyashree? C wrong. A wrong. Answer vandu D. Why it is 0? Current value da ketirukela. Ana vandu you see in the point la, let me say idoda potential vandu V da. Appadina tell me da, in the point la irukra potential oda value, I have connected a wire. This is what we are saying, short circuiting. Okay, short circuiting na no current flow. Appadina what will happen, in the point la irukra same potential da inge irukum. If there is no potential difference, there is no current flow. Okay, so if current flow is not there na, which means idoda answer ennada? 9 more likes I need 100 more likes. Okay, so tell me what is going to be the answer? We will be getting option D as the answer. Now let us go for the next question. We are going for the KVL rule. Okay, are you guys ready for the KVL rule? Okay, so ipo vandu pathena, you can just decide your current order flow. Okay, so when I'm just choosing the current order flow, I mean in the question they have given I3 vandu what is the value, or let's say what is the direction of I3, adu vandu question they have given. So appadina I'm just considering in the branch la irundha I3 na, I'm just taking this is what I1. Okay, so I1 is coming here, I3 is here, and some I2 will be flowing from here. Till this understood? Everybody understood till this? We are just, as per your convenience, you can do it, no issues. Okay, if you wanted to give some other direction also, no worries. Okay, and the final answer la there will be a change in the sign. That's the only thing. Okay, so now new haircut da, nalla irukelle. Okay, I don't want to get, actually I mean hairstyle or feedback if I'm asking now, I have only 2 options, bad or very bad. That is what the 2 options I have. 4 more likes guys, 200 likes again we need 4 more likes, so you can do it. Okay, then I will smile. Till that time I won't smile. So now just going back to the KVL. So inga we can just consider 2 closed loops. Am I right or wrong? We can consider 2. எனக்கே தெரியும்டா நான் I mean again இன்னைக்கு almost 1.5 hours you are just teaching, no ma'am, so we will say only good, every time we will say good only. So I know, no worries. Even I mean I know what to say, and the ஒரு statement இருக்கேலடா Oh, I forgot that. எப்பவுமே வந்து ட்ரூத் வந்து ப்ரூட்டலா இருக்கும். We should accept. So that's the thing. Smile, already 200 likes. Oh my god, wow, super, super. Let me check. Where is the session? Start pannalaya. Okay. Yes, this is the smiling time. I need to take some water next break I will go and I will take some water. Okay. Hey Lakshmi, thank you so much. I'm new to this class. For everybody is new to the class. We already dispersed this class. RE-NEET came, we came back. So இது வந்து எல்லாருக்குமே new தான். இல்லடா இந்த class, in the first break I will go. No worries. I3 will be 0. Soumya. Okay. Yes, say cheese. Okay, so now let us just discuss this now. Okay, we got our 2 minutes of break because of my hair, right? Okay, we have changed our mood. Okay, anyway, right time la da in the hair cutting ellame vanda I have did because definitely ma'am your teaching level is good. Thank you Hennit Mary, right? Thank you so much. At least you understood. Okay, there are many people, they won't say anything about my teaching and all. They will talk about my hair and everything. And they will say that, even I know it is not looking good, but they will say good. But they won't say anything about my teaching. Thank you, Hennit Mary. Thank you. Okay. So yes, I hope we got a proper break. Okay. Now இது வந்து insulting myself. So அது வந்து I don't want to continue. Yellamace. Yes, Deepthi. Okay. Yes, Hansika is starving for the answer. I won't give the answer. Okay. Yes, Hari Prasad, that is a relevant one. Yes, thank you. Thank you. Eye-opening one. Yes, your teaching is always the best, ma'am. Thank you. Jain, I'm continuing. I'll continue. Oh my god. When something is good, too good, we will not speak. Okay. So yes, go to the question. Yes, Marun Mani, right? Yes. Stop wasting time here. Just focus here. Why you are just deviating? Okay. So now what happened? So this is what the current order direction. Till this understood, now give me a heart. Till this, if you are understood, give me a heart quickly. So what I was just saying, we were just talking about the loop and we understood or loop irukku adula vanda I have given the direction of the current. So now what is the thing? I wanted to apply the KVL. Adukkaga you have to choose a direction, either clockwise, either anti-clockwise. Ipidi anti-clockwise, yeah, ipidi da. Okay, so now the thing is like I am going for clockwise direction. So idu da vandu ennoda clockwise direction. Okay va? So ipo vandu we know that the current order direction which we choose and in the clockwise anti-clockwise varulla adu vandu same direction na the potential difference across this resistor will become negative. We know that idu vandu 28 da adula pass pandra current vandu I1 da appadina the potential drop across this one will be coming as 28 I1. Till this understood, everybody? Till this understood? Thank you Diya, thank you so much. Thank you, love you too. Okay, so how are you? Hepsi, after a long time, where were you? We have started, it's already 97 minutes gone. So now the thing is like we know 28 I1 da namma potential drop. Adu vanda positive illa negative. As per this, tell me this is going to be and the potential drop vandu positive illa negative. What I said, nama current order direction, nama idukara the direction which we chose ellame vandu same direction na the resistance across and the potential difference vandu eppavume negative ah irukum. So negative na I can just put the value as minus 28 I1. Understood why this negative sign? Yena vandu eppavume the current direction we already fix it. Okay, you can take clockwise or you can take anti-clockwise. Now what I took clockwise da. Clockwise la paakumbodhu idu vandu negative da. So now again I have a question. Hi Aisha. Okay, now I have a question. Ipo vandu if I chose opposite direction. Okay, if I chose anti-clockwise. அப்போ வந்து இந்த potential drop negative ஆ positive ஆ? Quickly let me know. What I was asking, இப்போ வந்து clockwise தான். ஆனா வந்து now I just wanted to, I want some change. Okay. So அதுக்காக I was just taking this. Anti-clockwise. அப்படினா இந்த potential drop வந்து negative ஆகுமா இல்ல positive ஆகுமா? Very good Hari, very good Jayan, very good Maha, Hari Prasad, very good. It is coming as positive. Understood the difference? So now I got this one. And what about the 6V? What about the 6 volt? Higher to, in the clockwise direction பார்க்கும்போது இது வந்து higher to lower potential. எப்பவுமே வந்து direction பார்க்கும்போது higher to lower potential na, again that will also coming as negative. So minus 6. Now tell me what about 8? 8 வந்து positive ஆ negative ஆ? 8 வந்து positive ஆ negative ஆ? I'm coming to da Susila, right? Zuzi. 8 வந்து positive ஆ negative ஆ? Quickly let me know. Quickly, please let me know. As per whatever we have discussed, adula vandu what you got? Yes, it will also become negative. Yena direction paakumbodhu positive to negative, higher to lower potential. Understood everybody? Very good. So now the same question. Okay, now I hope you understood this. I will be put it as 0. Okay, now the same thing if we are taking clockwise. If we are, anti-clockwise, which means in the madri if I am taking now, what will happen? Can you give me the equation? So ipo vandu paathena we are going for the anti-clockwise. Yeah, anti-clockwise direction. So ipo vandu paakumbodhu idu vandu lower potential to negative, idu kuda lower to positive da, higher potential da, and this is in the opposite direction of current flow will choose. So all the values will become positive. Very good. All are positive. Very good. So now we understood. Now you guys have to give me the equation for this one. Idu kuda I'm just taking it as what to say, clockwise direction lada. I'm just taking. Can you give me the equation? What will happen? So idu vandu same direction da. So minus 54I2, and here we have the lower to higher da. So plus 12. Again inga kuda what will happen? Again opposite direction lada. So we will be getting plus 6, which is equal to 0. Are you guys understood till this? And the first two equations, how we are getting the first equation vandu purinjida illaya? Just give me heart if you understood. Illana give me a broken heart. Yes, of course. We will be just going for the cell part. Okay, after this. So you can just continue. In the question mudichadukapram we will be going for that. If you couldn't understand na, give me a broken heart. Oh Deepthi, broken heart. Don't say broken heart. Okay, so simple as sonnitena, we know that ipo vandu I2. Okay, what is the direction we chose? Clockwise. Appadina idu vandu positive ah negative ah? It will be coming as negative. Yena direction vandu same da. Ipo vandu inga vandu paakumbodhu in the direction nala I am just going like this. Clockwise na ippadi da irukumla. So idu vandu lower to higher potential, idu kuda lower to higher potential. So that will be both are coming as positive. Oh my god, Gayatri, why this much of broken heart? I want only one broken heart da. Okay, ma'am is rocking with the new hairstyle. Seriously, but I'm so disappointed after this hairstyle. This is not what I was expected. Anna, finally this is the output. You guys also expected something for the NEET 2026. Anna, everything has changed, no? So and the madri da idu. Okay, so right now you got two equations. Okay, so idhula irundhu paakumbodhu minus 28I1 will be equal to 6 plus 8 vandu 14 ஆக போறோம். So minus 14 will come as plus 14. So idhula irundhu you will be getting the I1 oda value vandu minus 1 by 2. Minus 1 by 2. Actually I was asked for feather cut. Ana vandu and the what is it that one real dialogue is there? No, na கேட்டது ஆனா எனக்கு கிடைச்சது. So அதுதான் வந்து difference. இது வந்து எந்த ஸ்டைல்னு தெரியலடா. Okay, so let it be. So now this is what the thing we got the I1 value. Now the thing is like you can just find. Okay, nama வந்து we should find this I2 value, right? Okay, sorry, I3 value தான் நம்ம வந்து find பண்ணனும், கரெக்ட்டா? So இப்போ வந்து பார்த்தேனா I1 is entering into the junction. I3 and I2 is leaving the junction. Correct? So in the second equation, you can find the I2 value as well. Once you get it, you can use the junction rule, which means I1 is the entering current should be equal to the leaving current, which means I2 plus I3. So idhula vantha I1 and I2 you will be get it from there. So I1 minus I2 will be coming as I3. Okay. Okay, done. Yeah, I know, Naveshri, I know. Oh my god, and the dialogue. Idana solli agado. Thank you, da. Thank you so much. Oh my god, a very good question. You can't understand physics. Till this you understood. Okay, the current electricity till this part, almost 75% we have finished. Adu vanda purinjada. No issues, Ansika. You just do one thing da. In the question, in the session you just go back and just do the same question. Do the same question. Whatever I'm saying, adu vanda appadiye practice pannikko. Okay. Adukapra you just do the KVL, KCL rule use pandra edachu oru question. You choose basic level question. Adukapra you just slowly increase the tough level. Okay, and question practice session irukum adula vandu we will be doing the same steps. Okay, we will do from the basic questions, then we will just level up. Don't worry, don't worry. Yes, Diya, justice. Nobody is giving the justice da. But paravala, let us see. Ma'am, Vitra hashtag la potu neenga news la vera mari pannunga. Avlo famous. Avlo fame ellame vandu ennala thaanga mudiyadhu da. Biology vandu innum 3-4 days la irukum da. Okay. So this is what the problem, Mano. You just tell me what is your target. Okay. So target vandu, let us say you just need 500 marks. Appadina definitely it is okay. You can just major vandu, you can just concentrate the rest of the subject. Ana vandu, if you need to get a admission in GMC na, you should study physics also. Okay. Yeah. Full Tamil, I don't know. Ana vandu Tamil movies ellame vandu I can understand. I used to watch. And ipo vandu na vandu Tamil la pesren. Grammatical errors ellame irukum. I can't read, but I can speak. Okay? So done? Let us just continue. Definitely, definitely. Okay. So now let us just go for, okay, now tell me what is the answer for this question? Okay, what is the answer? What is the answer for this? Of course, Darshan, I watched. Okay. Kerala Pailaga. Yes. So now tell me, what is the answer for this question? Very good. We will be getting option D as the answer. Now can we move on to the next question? Not the next question. I think I should, I have added some more questions, but I'm skipping it right now. Now let us just go for the another concept. Okay. Another concept da thevaiya irukku. Okay, another concept which means it is nothing but our energy, power and everything. Can you just give me the equation for energy? The heat loss, joules heating law. Can you just give me the energy equation? Can you just give me the energy equation? Energy equation, cells we will do da. I won't go anywhere. I will do cells. Cell only major confusion. Okay. Yes, we know that nama energy ki vandu we can just have different equations. We know H is equal to VIT, H is equal to V square by RT, correct? And I square RT. These are the equations we have, correct? So we can discuss later. Now you just observe here. Okay. Biology will be on in 3-4 days biology classes will start. Ma'am is traveling actually, so the classes will start. Actually these are all not planned or no. So we had some other plans. Ana cancel. We need to come back. So ma'am she couldn't come back. So that is the reason. Naatila Trishur Calicut. Okay. So now, yes, I square RT, yes, very good. So these are the equations, and now can you just give me the equation for power? Can you give me the equation for power, electric power? What are the equations for power? In the T, if you are removing now, because we know that power is equal to energy by time. So if you are removing the T, you will be getting the power order equation. Got it? So we will be getting VI, I square R and V square by R. These are the equations. Now let us move on to the cell part. Okay. Oh, thank you. Thank you so much, Diya. Thank you. Okay. It's making me so happy. Okay. So now tell me, we are going for the cell. So cell it is a device that will be converting chemical energy to the electrical energy. Ama correcta? Okay, so now we understood cell nama chemical energy vanda it will be converted as the electrical energy. So in the cell vanda sollumbodhu we should know three terms. Okay, first vanda nama internal resistance, next one the EMF, third one vanda nothing but nama terminal voltage. Okay, wow. So tell me what is internal resistance. What is internal resistance? Saravana, adu vandu enikku puriyalada. What you said I don't understand. Okay, so thank you, Hari. Thank you. Now you tell me, what is this internal resistance? What is internal resistance? We know that whenever we are talking about, okay, whenever we are talking about the what is a nama cell, okay, nama cell kulla anode irukku, cathode irukku, electrolyte kuda irukku, correcta? So cell illa anode irukku, cathode irukku, electrolyte irukku. So definitely in the electrons illana nama charges vanda when it is flowing through this, it will also exhibit some sort of resistance, correcta? Yes, of course. In the chapter mudichana I will give a break, definitely. I too want a break actually. Yes, inside the battery resistance is the internal resistance. When these charges are flowing through anode, cathode, electrolyte, it will exhibit a resistance. So definitely that is what internal resistance. Now my question is, what is EMF? EMF. What is terminal voltage? Or is it same? Is there any difference? That is what my question. Tell me, what is that is what my, you make physics easier. Thank you, Diya. Thank you so much. This is a kind of energy for me when you people are saying this. So now my question is, in the terminal voltage and EMF one the same illa? Is it a different, two different quantities, or it is same? Is there any connection? Something, can you just say? Yes, Susie, it is actually different. Very good, it is actually different. Yes. So now the thing is like, yes, both are potential difference da. Ana vandu konjam change irukku, which means let us say the battery is not connected with anything. Okay, in the battery vandu it is not connected with anything, which means adu vandu open circuit, there is no current flow. Note panniko, there is no current flow. And the time illa I'm just checking in the cell oda potential difference vandu check பண்ணும்போது I got a value. What is that value? EMF illa terminal voltage? Can you just let me know? So ipo vandu open circuit da, current flow pannala. Open circuit na enna meaning? Open circuit na enna meaning? It is actually open, no current flow. It is not a closed loop. Appadina there is no current flow. Anta time la in the cell kulla irukra illana and the potential across the cell vandu paakumbodhu I got a value. That is what EMF. Very good. That is what EMF. Okay. Now my question is, in the EMF vandu eppadi terminal voltage aagradhu? Okay, when I'm talking about EMF, when I'm talking about terminal voltage, actually vandu this is nothing but the potential difference across the battery da. But when it has become a closed circuit, which means idhula vandu current is started passing through it. Okay, current is passing through the circuit. Okay, va? So now the thing is like, you should understand, when it is passing through the current is passing through the circuit na, and the time la I will call this as the terminal voltage. Purinjidada? Okay, when there is no what is a battery, when there is no connection, if it is an open circuit, adu vandu EMF da. Okay, idu kuda oru terminal voltage da, ana idu vanta I can call it as EMF specifically because current flow anga zero da. Okay, I which is equal to 0 da. If there is a current flow, which means idu vandu oru closed circuit na, the potential across that will be, call it as terminal voltage. Purinjidada everybody? Yes or no? Everybody got it? So this is what the thing. Yes, yes. Okay, this is what the thing. Both are potential difference. The both are work done. Ana vande, if it is an open circuit, no current flow, na, we will say it is EMF. If there is a current flow, na, I will call it as terminal voltage. So what will happen? What will happen? I will represent a cell like this. Idudha vande the representation of a cell. Idudha vande EMF. Idudha vande internal resistance. So, in the case of internal resistance order role vande, it will be highlighted. Okay, in the internal resistance order role vande highlight agra oru moment ennana when there is a current flow. Otherwise, this internal resistance no problem at all. Okay, if there is no current flow, that is what I said. If it is an open circuit, na, in the internal resistance vande no value, we won't consider. And the time potential difference will be EMF. Now the thing is like, if this become a closed circuit, this is what our R, this is what our EMF, this is what our external device or let's say external resistance we are adding. Appadina in the moment what will happen? The current will flow. Okay, correct? The current will flow. When the current will flow, now what will happen? Charges it will experience a resistance, and of course we know that in the external resistance there will be a potential drop. When current is passing through a device, current is passing through the resistance, what basically will happen? Anga oru potential drop irukkum. Got it? Got it? So now inga oru potential drop irukkum. Vera edaachu oru point la potential drop irukkiradhukku chance irukka? Can you just let me know? Yes, Dadia, in this chapter mudichadukku appuram I will go out, I will drink some water, and after break we will again continue with semiconductors. Okay. Yes. Sure, I'll drink water. No worries. Just hardly 20 minutes adukappuram, because if I'm going now, you people will go. You will run away. So I don't want that to happen. No break at all. Okay. So now tell me, inga there is any other option? Yes, IR. Inga kuda oru potential drop irukkum. Got it? So ipo current pass பண்ணும்போது internal, which means in the cell kulla there will be a potential drop, as well as in the external circuit nala there will be a potential drop, which means in the EMF is actually due to, or EMF is actually distributed for two potential drops. Which one is through the resistance and another one is due to the internal resistance, which means I can say IR, which means this potential drop, plus I into small r. Got it, everybody? Got it, everybody? Yes or no? Yes or no? Please let me know. And guys, don't forget to enroll in the RE-NEET free crash course. Description box la link irukku, first link. Okay? Yeah, I'm too strict. Yes. So ipadina I got this. So now tell me, what is this IR? And the IR na in the point la irukra potential difference da. Appadina I can just replace it. So EMF will be equal to the terminal voltage plus the voltage drop due to internal resistance. So now I'll be getting E minus IR, which is equal to V. This is what the case of discharging. Purinjidada. This is actually the discharge, which means in the cell irundha actually the charge is going. Now the thing is like, nama mobile allame we will charge, no, and the charging time, okay, when we are charging the mobile and all, what will basically happen? Of course, Damano, I will cover everything. Don't worry. You just check the upcoming live sessions, you will get to know. Okay, ellame the schedule arke, we will take everything. Okay, so now you just tell me. What I was asked, I forgot the question. I was asked something, right? Charging. So we are just charging the mobile phone. So at the time, what will happen? So if the current should flow from one point to another point, na, inga higher voltage arkanum. Correct? So we are actually giving the current flow to the cell. Appadina terminal voltage high arkanum. Okay, va? Got it? Okay? Got it? Yes or no da? Don't what is a roast me. Now you should tell the answer. I have two questions. Okay. While charging, terminal or EMF, which one is higher? Okay. while charging, terminal voltage or nama EMF, which is going to be large? Tell me the answer. Tell me the answer, everybody. While charging, very good, Manas, right? Manasi, okay, I forgot your name. Okay, terminal da high irukanum. So appadina while discharging, nama EMF da high irukanum. So discharging oda equation da, that is Hello guys, can you able to see me? Please let me know. Hello, hello, hello. No. Yes, 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 yes. Okay, okay. Thank you so much. Yeah, yeah, okay, 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 close. So, can we restart again? Yes or no? Is everything okay? Yes, let's rock it. Yes, guys, let us rock it. So what we were discussing about EMF, terminal voltage, and of course, what to say, this thing, what was that? Internal resistance. Okay, my flow is also got stuck. Okay, so let us just try to get it back. So discharging, charging, we have discussed. Now the thing is like the cells in series. Okay, the cells in series, no complications at all. So the thing is like if it is in series, something like this, okay, what will happen? Let us say this is E1, this is E2, this is E3. So how we will be doing it? E1 plus E2 plus E3, correct? Now the internal resistance internal resistance is actually the same way how we will be. Okay, internal resistance na it is same as our resistance. So R equivalent in series, how we will do? R1 plus R2 plus R3. Correct? So this is what happening. So in the series na there is no problem. We can just simply add it. And now let us say ippadi da nama series. Okay. So idu vande E1 da, idu vande E2 da. Appadina what will happen? What is going to be the equivalent EMF? Can you give me the answer? இப்போ வந்து இப்படிதான் நம்ம சர்க்யூட் இருக்கு. இதோட internal resistance வந்து R1, இதோட internal resistance வந்து R2. So I want the equivalent EMF as well as I want the equivalent resistance. Can you give me the answer? Can you give me the answer? Everybody tell me. Very good. Quicker give me the answer da. Even I got I lost my flow, but I wanted to get it from you people. Okay, இது வந்து equal na 0 ஆகும்டா. ஆனா வந்து it is not mentioned, no, so we can say it will be E1 minus E2. This is what E equivalent. Now can you give me R equivalent in this case? What is going to be R equivalent? Tell me what is R equivalent. Very good. It will be R1 plus R2. Got it? So there is no change for resistance. எப்பவுமே வந்து resistance, internal resistance ஆ இருக்கட்டும், external resistance ஆ இருக்கட்டும், we will deal as how, the usual resistance, how we will solve, அந்த மாதிரி same we will do. புரிஞ்சுதாடா everybody? So now the thing is like, இப்போ வந்து I have kept n cells in series. Okay, I have kept n cells in series. Equal cells. Okay, EMF வந்து same da, E da, resistance, internal resistance வந்து ஒவ்வொரு செல்லுக்குமே வந்து R da. அப்படினா I need to find the current which is flowing through it. Okay, I wanted to find the current which is flowing through it. So which will be coming as NE divided by the external resistance plus the internal equivalent resistance. So equivalent resistance series la in the N resistance Y minus R. In the direction பார்த்தா போதும்ல. So if it is on the same direction, இது வந்து higher lower. ஆனா வந்து இங்க பாக்கும்போது what is happening da? Higher lower higher, which means it will be cancel. Okay, equal na it will become 0. Okay, புரிஞ்சுதா? So right now understood? Yes or no? Yes or no everybody? Okay, please. Oh my god, one second. Okay, yeah, fine. Okay, so now we got this one. இப்போ வந்து current if you need to find na, it will be coming as NE divided by R plus NR it will come. Now the thing is like for the parallel connection, okay, cells in parallel. So இதுக்கு வந்து let us say we have two cells E1 and E2, internal resistance வந்து R1 and R2. அப்படினா நம்ம value வர போறது வந்து E1 R2 plus E2 R1 divided by R1 plus R2 தான் நம்ம equivalent EMF. Okay, நம்ம equivalent EMF வந்து இப்படி தான் இருக்கும். And what is happening to R equivalent? It is nothing but R1 R2 divided by R1 plus R2. புரிஞ்சுதாடா everybody? Yes or no? Yes or no? Everybody please let me know. Everybody please let me know. Okay, now we will take the, we will Lakshmi. We will do it. No worries, no worries. Okay, in the class முடிஞ்சதுக்கு அப்புறம் you can just check in the comment box. You can just find it. Okay, so இப்போ வந்து we got this equation. Now the thing is like, let us say if I'm just connecting n cells. Okay வா, அப்படினா what will happen? Parallel தானா? So equivalent potential difference வந்து எப்பவுமே same இருக்கும். கரெக்ட்டா? So now can you give me the current order value? Can you give me the current order value? So இப்போ வந்து I have what is a n number of cells na, I can say that the current order value வந்து n into E divided by n into R plus நம்ம R oda value. So this is what in the parallel connection la, this is how we will be getting this value. So you can study these values. Okay vada. So now we have the Wheatstone bridge, right? Wheatstone bridge is there. What is happening in Wheatstone bridge? Wheatstone bridge is actually used for finding the unknown resistance. Okay, in the equations ellame vandu you have to study da, and don't go behind how this come and all the derivation. Adu vandu konjam lengthy da. Don't go for at all. Everybody don't go for it. Just study the equations, that is enough and more. Okay, so now the thing is like, very good, Hajir, right? Yes. So now the thing is like, we need to know what is Wheatstone bridge. So if I have a resistor, I don't know the value. So using a balanced Wheatstone bridge, I can find the unknown resistance. Idoda principle vandu nama KVL rule da. Okay, nama KVL, KCL rule da. Idoda, what to say, the principle behind it. So ipadina, I can say that now I have 4 resistors. Ipadi I have connected. Okay, இங்க வந்து ஒரு galvanometer இருக்கு. So this is how the circuit is. Okay, so let me say this is P, Q, R, S. So இப்போ வந்து I can call this as balanced bridge. Okay, I can say that this is a balanced Wheatstone bridge. When I can say this is a balanced Wheatstone bridge, I can say when this galvanometer shows 0 deflection. When I am saying galvanometer shows 0 deflection, what is the meaning of that? There is no current flow through this wire. Understood everybody? Are you guys getting what? Thank you Manchu, thank you so much. Are you guys getting what I am saying? Okay, galvanometer reading வந்து 0 na, I can say that அங்க வந்து current flow இல்ல. அப்படினா I'm just redrawing this diagram. So இப்படி தான் நம்ம diagram வர போறோம். So this is how it will come. Now P இருக்கே, Q இருக்கே, and R இருக்கே, S இருக்கே. Okay, so when this will be balanced, okay, what is the relation when this will be balanced? When this P and Q, or let's say P by Q is equal to R by S na, definitely we will be getting the balanced Wheatstone bridge. So idilirundha and the relation use panni you can just find, let us say P is the unknown, so you can find the P value. Got it? Yes Palani, thank you Mansi. Yes, Doria. Izu is more better. Okay. Yes, sure, you can ask. Okay. So this is what the Wheatstone bridge. Now, in the madri we have the meter bridge also. What is actually happening in meter bridge? So basically, anga kuda oru unknown resistance irukum. Okay, anga kuda oru unknown resistance irukum. How we will be finding the unknown resistance is very simple. Yena nama meter bridge la 1 meter length la oru wire irukum. Correct? Meter bridge la 1 meter length la we will be having a wire. Anta wire la definitely we will be having a galvanometer and we will be connecting the 2 resistors, and whenever we move this what is in the galvanometer connect pannirukra and the wire vandu, whenever we are moving it, what will happen at some point on the galvanometer la it will show 0 deflection. Again the same condition. Again the same condition what we have explained previously. Nama Western bridge oda condition arke. So anga kuda what we will do? We will use the same thing. We will be using the same thing. P by Q which is equal to R by S. Ana in the R and S vanda actually vanda length da. That is what the problem. We too don't know what is the resistance of the length of the, what is the resistance of that wire. We only know, ipo vandu in the case la sollitena, P vandu unknown da, Q vandu we know it. We know this length vandu we know. Okay va? Are you guys getting what I'm saying? So, idha vandu let us say 1 meter length il irukra nama meter bridge la wire. And at some point, okay, at some point I'm getting galvanometer as 0. Okay, galvanometer is showing 0 deflection. So, Western bridge madri irukku right now. Okay, idu vandu oru resistor da. Till this length, let me say this is what the length L. Till this length, what is happening? What is happening? Adu vandu I can consider this as a resistor. Okay, now another wire is here. Another wire is here, which is having a length 100 minus L. Now the thing is like, I can replace with this R and S. What will happen instead of that? I can just go for what? R in, here I can go for 100 minus L divided by L. Same da. Western bridge and meter bridge vandu same da. Ana vandu idhila 2 resistors vandu we will replace it with the length. Got it? Understood? Okay? Yes. So now the thing is like, we are going for the, what we have after this. This is the major things, right? Yes. So almost done. So this is what we need to learn from it. Now let us quickly go for the question. Simple or question da. Okay, simple or question da. Let us just try to do it. In the circuit shown in figure, the heat produced in the 5 ohm resistor. Idha vandu nama heat produced irukra 5 ohm resistor. Okay va? So idhula vandu paathena due to the current flowing through this, okay, in the idhula vandu current is flowing, some current is flowing. Adanala there is a heat loss which is nothing but 10 calories per second. And the heat loss and the energy vandu they have given, which is going to be 10 calories per second. In the current electricity will continue for again 20 more minutes. Adikapram we will go for a 10 minutes of break. Adikapram semiconductors we will finish in 1.5 hours. Okay, got it? So now in the 5 ohm la current vandu pass பண்ணும்போது what we understood anga vandu there is a loss of 10 calories per second. Till this understood? It is very simple da. Same nama Western bridge oda R by S which is equal to nama length divided by 100 minus L. And the resistance vandu we will replace. Okay, resistance vandu we will replace in terms of length. Yena resistance oda equation enna? Rho into L by A dana. So R will be proportional to L and we will be substituting that. Got it? So ipo vandu paathena I'm just going to redraw this diagram. Okay, I'm just going to redraw this diagram. So 6 plus 4, 10 ohm da. Now we have 5 ohm here. Okay, so this is what the circuit. So now tell me, let us say, okay, if I'm telling you, guys, smash the like button. Yes, I don't have the energy to tell, but for me, Manju is saying. So now tell me, if I'm giving you an answer, okay, just imagine in the question, okay, this is the circuit I have given to you. Now, I'm telling you, in the, in the 5 ohm, we can say that the current which is flowing through 5 ohm, let us say 10 ampere. Are you guys getting it? This is a different question. Forget about this. I just want a simple answer. So now, in the 5 ohm, pass pandra current oda amount 10 ampere. Appadina, what is going to be the current which is passing through 10 ohm? What is going to be the answer? What is going to be the answer? What is going to be the answer? Idhula vandu pass pandrathu 10 ampere da. Appadina in the 10 ohm la pass pandra current oda value. Ma'am, you are really brilliant. Not every can understand physics, but you are teaching well. Thank you so much, da. Thank you so much. Think well. Everybody, simple ana oru question. Inga vandu pass pandra current vandu 10 ampere. Appadina inga vandu pass pandra current oda value. Yes, Giri. Yes. 20. resistance வந்து அதிகமா இருக்கேலடா, resistance வந்து increase ஆச்சுனா definitely நம்ம current ஓட value வந்து reduce ஆகும்ல. So இங்க வந்து 5 ohm resistance கம்மி தான். So more current will be flowing through it. அப்படினா இங்க வந்து 10 ampere na definitely அது விட I mean 2 times அதிகமா இருக்க அந்த next branchல. So definitely இங்க வந்து current வந்து it is going to be less, which will be coming as 5 ampere da. Very good, Lakshmi. Got it? Everybody understood? So that is what a basic understanding, or forget about it. Okay, if you can't just think in that way, na, just forget about it. Now let us do this. Okay, what they have mentioned, they have given the energy value, right? So let us say I'm just telling you, idu vandu I1 da, inga vandu pass pandra current vandu I2 da. Okay, idu vandu series la anadala, this is also going to be I2. Till this understood? So now imba vandu I mean the what is it, the current is I1 and 5 ohm da resistance varudha. What is the energy or equation? What is the energy or equation? Energy na, it is nothing but I square R da. Energy vandu they have given 10 da. Okay, 10 calories per second da, and inga vandu current na I1 square into resistance vandu 5. Appadina I will be taking this 5 over here. 10 by 5 will be coming as I1 square, which means I will be getting I1 as root 2. Till this understood, everybody? Give me a red heart if you understood. Till this understood, na? Give me a red heart. Everybody. Everybody. Till this, in the I1 oda value vandu root 2 da. Till this understood, na? Give me a red heart. Then only, if everybody is giving red heart, then only I will move on to the next step. Everybody, I want everybody's respond. Yes, very good, very good. So ipo vande energy oda equation vande I square R da, inga vande current na I1 da and resistance vande R da. Question la energy is given. So idhila irundha I found I1 which is equal to root 2. Next step. I know that the potential across both this one is going to be same. Can I say that? Okay, the potential across this 5 ohm and the potential across 10 ohm will be same. Can I say that yes or no? Y or N? Give me the answer. What I'm saying, the potential idu vandu parallel la. So adanala the potential across 5 ohm and potential across 10 ohm vandu it is going to be same. Am I correct or what? Yes or no? No, Sina. Adu vandu correct da. No, Madi, it is yes. Okay. So this is the thing, just observe. So this is what the circuit, okay, this is what the circuit, idu da vandu nama 5 ohm, this is what our 10 ohm, idu vandu parallel dana. So what is the potential across these ends? Same. Okay, so now I can say that inga vandu pass pandra current I1, inga vandu pass pandra current I2. Appadina can I say that 5I1, inga irukra potential drop enada? What is going to be the potential drop? Current into resistance, ma'am. Even you don't know that. I1 into 5. So 5I1 it will come. Next one the idhu da. Okay. So what is going to be the potential drop? Can you give me the answer? The resistance, sorry, the potential across 10 ohm. What is going to be the value? We said it is same. So what I can write? 10I2. Am I right or wrong da? Oh my God, Kakashi, it's the biggest problem. Concentration, focus. Very good, very good. So now I am equating this and I got the value of I1 previously. What was that? 5 root 2, which is equal to 10I2. So now I am just taking this 5 by 10 root 2, which is equal to I2. Can you just give me the answer? Everybody understood till this? Yes or no? In the I2 value, till that everybody understood. I1 we got it, I2 we got it. So now we can find the value of energy dissipated from here. Now we know that I2 into the current which is flowing through the circuit into adoda resistance da nama energy oda value. The power generated in the 4 ohm na, I know in the 4 ohm la pass pandra current vandu I2 da. So I2 oda value vandu what we got? I forgot. What is the value? Hey. What is the value? What is the value? 5 by 10 will be 1 by 2. 1 by 2 root to 2 it will come. So 1 by root to 2 into root to 2. So it will be coming as 1 by root to 2. Okay. So now, reveal the answer. Hey. Okay. So now, energy is equal to I2 value வந்து 1 by root 2. அதோட square. ஏனா I square. Correct? I square தான். So I square into resistance வந்து 4. Now you can give me the answer. What is option A, B, C எல்லாமே இருக்கு. You can give me the answer. Everybody. Can't get it fully. Half you got it right. Session முடிஞ்சதுக்கு அப்புறம் you just go back. You will get it. Okay. Simple concepts da. Simple concepts. இங்க வந்து ohms law மட்டும் தான் we are using. Okay, and we should know the equation for energy. Energy oda equation enna I square R. Andhula irukra current purinjidna no issues. Resistance vandu directa they have given. So first vandu we know that anga irukra energy loss vandu 10 calories per second da. That will be equal to what? I1 square into R. Adilirundha we found I1. Adukapra what we have done? We know that definitely logically also you can just think the first concept I have told you na inga vandu root 2 na what will happen root 2 by 2 it will come here correct ah ena resistance vandu double ah irukke so current will reduce to half so inga irukkiradhu root 2 na instantly you can say this will be root 2 oda half got it so like that way you can just do finally you made physics easy for me thank you so much I square R and time அது வந்து power da don't write your name as hero okay power வந்து I square RT இது வந்து energy da unit பார்த்தாலே தெரியும்ல calories per second okay energy by time da okay வா sorry இங்க வந்து they have mentioned the power hey you are right you are the real hero ஆனா வந்து இங்க time we don't need to consider ஏனா வந்து this will be same no so that is what we are we are just skipping the what to say nama t value ஆமாடா okay இதுல வந்து t per second இல்ல so that is why we are skipping it you are right you are the hero I am the villain okay let us go for the next question. You are such a gem. Oh my God, I'm getting a lot of, promotion. Thank you so much. Okay, so what is the answer? What is the answer we are getting? 2 calories per second, right? If I'm not wrong. I check the answer. Yeah, option B. Done. Let us go for the next question. I bought the crash course. Yes, everyone should buy the crash course. Yena vanda zero price da. Okay, nama crash course oda price vanda zero da. And you will be getting test series, full length test series. You will be getting the 2 more questions, Saravana. 2 more questions. Adukapram we can just wind up this. Then we can go for semiconductors. I'm also done with current electricity. Even I'm having neck pain. I don't know. It has been a long time. No, in the madri long sessions, after 9-10 days going for the long sessions. So, yenakku kuda difficult daanda. Almost 2 hours of standing da. Okay, I am in the crash course. Very good. So, in the session you will be getting the test series. So, do the questions. Adukapra leaderboard kuda you will be getting. So, anneki vandu whoever has joined or whoever has attempted the exam, adu base panni da leaderboard varum. And also AI irukku 24/7 you can have the doubt solving. Idellame vandu advantage da. Okay, so you can see the crash course link vandu nama description box la first link. So in the question mudichirukka, let us go for the another question. Yes. 2 electric bulb. How many bulbs we have? 2. Adoda power enna 25 watt. What is the voltage? 220 volt. And 100 watt 220 volt. Another one. Are connected in series. No issues. Series parallel edach irundhalum paravalla. We will do it. Of course, Mansi, it is a very simple chapter. Semiconductors, if possible, I'll finish in 1 hour. Okay, but I have to finish this in 10 minutes. Okay, come back. Okay, if the 25 watt and 100 watt bulb drawn power P1 and P2 respectively, then, okay, so in the question you will be having a confusion. Ma'am, 25 watt and 100 watt, adudana power, then why they are again asking P1 and P2? Do you have that doubt? Yes or no? Yes or no? Please let me know. Because when I was studying in the 12th grade, I had this doubt. That is what I'm asking. So, enna madri edachu students irukka inga? Yes, 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 yes. நம்ம எல்லாமே வந்து same wavelength டா. So, why this problem? Okay. I don't know. IDK is I don't know, right? Yes. So, I don't have IDK. Okay. Yes, yes. So, let us go for it. So, I'll explain this, then we can move on to the question. So, actually, what is that value? 25 watt and 220 volt. Actually, வந்து சொல்லிட்டேனா, it is actually, இப்போ வந்து அந்த bulb, if I am connecting in 220 volt, note பண்ணிக்கோ, இப்போ வந்து அந்த bulb வந்து I am connecting with 220 volt. Okay. அப்படினா, that will produce a power of 25 watt. இப்போ வந்து if I am placing it to different voltage na, அது வந்து different power it will come, different power இருக்கும். Master medicos we will definitely resume da, ஆனா வந்து right now கொஞ்சம் priority வந்து நம்ம re-NEET students-க்காக we are giving da, and I think once நம்ம team எல்லாமே வந்து set ஆச்சுனா again we will be starting this medicos batch. Okay, master medico we will continue, no worries. Okay, so yes, Poggala Jagadishwari, right? If I'm pronouncing it wrong, please. Okay, so now. Okay, so no more doubts right now. Just focus on this, because I will lose the connection. I will repeat the same thing. That will irritate you people, and this will be again become a problem. I don't want any kind of problem. So let us just continue. So we have the bulb, and the bulb வந்து 220 volt ல பக்கா perfect connect பண்ணிட்டேனா, what is the power? 25 watt. Understood that bracket wala thing? Do you got what is given in the bracket? Yes or no? Yes or no? Yes or no? Give me quickly a response. Give me a quick heart. And second one la kuda same da. 220 volt la ipo vanda I am connecting that bulb na, I will be getting 100 watt power. Okay va? Ipo vanda if I am connecting it with 240 volt na, I won't get this power. It will be something different. Okay. So now, very good. Thank you so much. Okay. So now what happened? This is in series. And in series, I'm giving 220 volt. Now I have a question da. Now I have a very brilliant question. You should give me a brilliant answer too. What is that brilliant question? I forgot. I'm that much brilliant. No. What was our VR? Yes, 220 volt. 220 volt in series. Appadina, can I say that in the two bulb irukella, first one is there, second one is there. So in the two bulb ku vanda, both will get the same 220 volt. Yes or no? Please. Hey. Guys, don't. That is also nice na. We can get to know how many of you are doing this. Yes. No. Very good. Super perfect. So actually vanda, if I am connecting this to 220 volt na, both will be getting different voltage. Yena idu vandu series. Parallel na, no connection, no problem. Okay, it will get 220 volt. It will give the same power too. புரிஞ்சுதாடா? Everybody understood? ஆனா இந்த வாட்டி 220 volt தான் given. இது வந்து சீரீஸ்ல தான் இருக்கு. So இதுக்கு வந்து கிடைக்க போற பொட்டன்ஷியல் வந்து டிஃபரெண்டா இருக்கும். இதுக்கு வந்து கிடைக்க போற பொட்டன்ஷியல் வந்து டிஃபரெண்டா இருக்கும். அப்படினா my question is, will it give 25 watt power and this will give 100 watt power? Yes or no? Y or N? Give me quickly. Everybody tell me. So ipo vandu inda oru connection la both the bulbs will, we understood both the bulbs will never get 220 volt. Appadina the same power it will get, which means idukku vandu 25 watt mentioned madri, idukku vandu 100 watt mention panna madri, will it get? No, it will never get. Correct ah? Yena vandu idu vandu 220 volt. The potential across this one should be 220. Then it will give 25 watt. The potential across this one should be 220 volt. Then it will give 100 watt. So at this point, this is not possible. Okay, it cannot give 25 watt. It cannot give 100 watt. Understood? Idu vandu konjam confusing ana question da, ana vandu calculation and the method vandu easy da. Understood this concept everybody? Give me red heart. I'm starving for red heart. Please let me know. So ipo vandu two bulbs irukke. Idukku vandu 220 volt correct we have given na, definitely it will give 25 watt, 100 watt. ஆனா இந்த வாட்டி we have given in series mode. அப்படினா இதுக்கு கிடைக்க போற voltage வந்து different இருக்கும், இதுக்கு கிடைக்க போற voltage வந்து different இருக்கும். So definitely the power also going to change. So அந்த டைம்ல தான் நம்ம P1 and P2 ஓட relevance. So இதுதான் வந்து P1, this is what P2. Okay, thank you so much for the red hearts guys. Thank you so much. Thank you so much. Okay va? So இந்த மாதிரி questions கிடைச்சேனா how you will solve. Okay va? Question வந்து புரிஞ்சிடுச்சு. What we need to find, you got it. Correct. So now P1 and P2 தான் நம்ம வந்து find பண்ண போறோம். So first வந்து understand. இப்போ வந்து இந்த bulbல, okay, இப்போ வந்து இந்த bulbல it is mentioned, okay, it is mentioned 25 watt 220 volt, 25 watt 220 volt. அப்படினா இந்த 25 watt வந்து if I am connecting in 220 volt pakka I will get it, which means can I find the resistance? Can I find the resistance? How I can find the resistance? How I can find the resistance? Tell me. How I can find the resistance of this bulb? ஏனா அது வந்து change ஆகாது. Okay, the resistance of the bulb வந்து even if you are giving 220 volt, 240 volt, 520 volt நாலும் resistance வந்து change ஆகாது. So in the bulb ஓட resistance வந்து can we find it or what? Can we find it or what? ஏனா எனக்கு இருக்கிறது power இருக்கு, எனக்கு voltage இருக்கு. அப்படினா to find the resistance, can I use this equation? Can I use this equation? Can I use this equation? Yes or no? Yes or no? Of course I can use. So R will be equal to V square by P. Okay, I will be getting V square by P. Exactly for the second one also, 100 watt 220 volt. So again I can find the resistance R2, which as 220 volt square divided by 100. Till this understood? Till this understood? Everybody, till this understood? Yes or no? Yes or no? Everybody, can you give me the answer? Till this you guys understood or what? 1 second. Okay, so right now ipo vandu you got the R1 and R2 value. So nama next step vandu it is to find the power. Okay, so power na enna, we can just find, idu vandu series la da irukella. So series na I can find the current order value. Okay, I can find the current order value. Yena the current which is passing through P1, sorry, the bulb 1 and bulb 2 will be same. Yena adu vandu connect panni irukkiradhu series la tha. Okay, it is connected in series. Adanal current will be same. So in the current vandu ennala find panna mudiyuma illaya? Of course I can. Correct. In the current order equation enna voltage adu vandu 220 in the case la. Okay, divided by the resistance. What is resistance? R1 plus R2. Adu vandu already we found in the previous case la. Resistance of the bulbs vandu we already find it out. So 220 divided by R1 plus R2, you will be getting the I value. Next vandu again power da. Okay, next vandu again power da. So power vandu how you will be finding it? You got the current. So P1 vandu, what is going to be P1? I square R1, P2 vandu I square R2. So R1 and R2 we already found it, and I vandu you can just find it using this equation. And now tell me which is going to be the right answer. Which is going to be the right answer? Which is going to be the right answer? Everyone should say. Yes, in the question kapparam break da. Then we will start with semiconductors. Idoda answer vandu quick you guys have to give me. Adudha vandu condition. Quickly tell me da. R value ah. Small r edukkuda. Capital R vandu we will be finding it from here. Hey, where is this? Okay, so R1 vandu 220 square divided by 25. R2 vandu 220 square divided by 100. Adudha vandu R1 and R2. VI use பண்ண முடியாதுடா, ஏனா வந்து இதுல வந்து V is different na. So understand, if you need to find, if you need to apply P is equal to VI, you should know the potential across this one. So far we don't know, we have to find it, right? And the potential na enna, the current which is passing into the resistance. Correct? Again you are applying this thing. Hero understood. Power is equal to VI. Correct? What is V? Idoda in the first bulb across irukra potential da. And the V value we will find it I into R. Okay, I into R1. So we have to do this. Again we will be getting the same result, I square R1. Okay, so there is no point of doing VI. You can straightly go for I square R1. Very good, very good. So we will be getting the answer as option A. Now let us quickly go for a breakdown. Okay, I think we can just come back by 7:30, right? 7:30 will work, right? Yes or no, yes or no, yes or no? Yes or no, yes or no, yes or no? 7:30 is fine? Okay, so we will be come back by 7:30 and continue with okay, we will be continue with semiconductors. Thank you, Kallu. Thank you so much. Okay, so Marakama, everyone should come. Okay, wow. Don't forget, everyone should come on time. 7:30 sharp. I will check whoever is there. Illana avloda. Okay, nama likes kuda we can just keep a target. Super arkale. Okay, so see you guys. See you. We will meet after this 10 minutes. Okay, see you. Bye. So bye bye guys. Hello everybody. Hello, 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 hello. Are you guys here? Everybody took a proper break. Yes or no? Improvement exam, all the details I have shared, you just check in YouTube, videos section. Adil, I have explained everything. You will get all the information. Okay, let us continue. Are you guys ready? Ready, everybody? Ready na? Give me a fire. See na, after the break, what happened? This is why I don't want to give a break. Okay, yes. So now we are going to start with the semiconductors. So semiconductors la first the important part namma intrinsic and extrinsic semiconductor da. So now tell me, what is intrinsic, what is extrinsic? Everybody tell me. What is the major difference? What is it? All the details I want. You should tell me. Yes. Hi, hey, hello Lakshmi. All good. Hey, semiconductor, I think no one is interested. Come on guys, like the wonderful session. Yes, Durga, where were you? I missed you from the beginning. Yes, intrinsic is pure. Extrinsic is nothing but we will be adding the impurity. Why we are adding impurity? What is the reason for it? Yes, pure form. No impurities, nothing other than the intrinsic and extrinsic. What is that? Why we are adding impurities? To increase the conductivity. Yeah, now when I'm talking about intrinsic semiconductor, now it is basically, actually I am also recollecting things, okay? While you people are giving the points, I'm, okay, I remember this thing, okay? So actually in the intrinsic semiconductor, covalent bond will break. Yeah, now while we are giving temperature, this covalent bond will break. So equal amount of electrons and holes will be generated. Understood everybody? Yes or no? So covalent bond will break. So electron hole will be generated. Number of electrons will be equal to number of holes. And conductivity when they compare பண்ணும்போது, it is going to be less. And there is no impurities, nothing. Got it everybody? So next point என்னன்னா, okay, once again. Okay, next point என்னன்னா, hey, why this is behaving like this? Okay, so next point என்னன்னா, we know that நம்ம energy gap it is again small and next one is நம்ம extrinsic semiconductor தான். So அதுல பார்த்தேன்னா we will add impurities. While adding impurities, we will again increase the number of charge carriers, which means we will be again go for Lerin Mam lessons and lays. Hey, don't tell da, I'm feeling so hungry. Okay, I didn't even had anything because I didn't get time today. So don't talk about lazy food, nothing. Don't talk anything. Okay, it's so bad. Okay, so now what I was saying, feeling depressed. Ana vandu, this is the rising moment. We can crack RE-NEET la, we will be getting good score. அதுதான் வந்து the answer for the CBSE result. அப்படியே நினைச்சுக்கோடா. எப்பவுமே வந்து டிப்ரெஸ்ஸா இருக்க, இல்ல நான் வந்து I'm feeling low, I'm demotivated, அந்த மாதிரி அதான், there is no point da. Okay, ஏன்னா வந்து நம்ம வந்து we are in a competitive field. Okay, இப்போ வந்து if we are getting low na, others are getting the chance. That is what you should believe. Okay, எப்பவுமே we have to be, it is very difficult to become positive. Okay, but you have to become positive. We don't have any other option. ஏன்னா நம்ம society வந்து அப்படியே இருக்கு. Okay, if you are becoming low, someone will be replacing it. So that is what the fact. So always do try to be active, always try to be the best always. Okay, hero, just go back and just check the videos. Adula vandu correct ah idellame teliva sollirukenda. Okay, so now I'm here only, ma'am, from the beginning. Yes, Durga, yes, but you didn't text me, you didn't give any comments. That is what making me so sad. Okay, so let us just continue da. Okay, so now we have eccentric semiconductor. So adula enna, we will be adding some impurities. Maybe this impurity will be 13th group element, maybe it will be 15th group element. So while adding the impurities, basically we are increasing the number of charge carriers. Increasing the number of charge carriers, now what is the meaning? Conductivity will increase. Conductivity will increase, now that is what the practical applications ellame vanda, that is what the major thing. Yes, Manchu, tell them for me. Okay, yes, it will be there da Shravan, it will be there, ana vandu 3-4 days irukum. Okay, 3-4 days ku appuram da sessions will start. So now we understood. Okay, just come back. Okay, so we understood about extrinsic semiconductor. adula vandu paathena n type irukku, p type irukku. So how we will be making n type? N type na more negative na, there should be more number of electrons, right? More number of free electrons should be there. So adukkaga we will be adding 15th group element. Now let us, if I'm talking about p type na, p positive na enna da, it is nothing but nama positive the number of holes vandu adhigama irukum. So number of holes vandu adhigam na, what is the meaning? We will be adding 13th group elements. Okay, so this is what the basic idea about this. So now we know n type irukke, p type irukke, and there are more such. We have to do many questions. Yeah, okay, yeah. So this is what the thing. Idhula vandu number of holes and number of free electrons vandu, it is not going to be equal. Now the thing is, like in the p and n type junction vandu, we can keep it together. Okay, we can keep it together. So now definitely what will happen in the p type la irukra holes and n type la irukra electrons will start flow from both the sides. Yena in the holes paakumbodhu inga yaru holes vandu positive. The positive holes will be attracted with whom? Tell me everybody tell me. Yes, of course vandu actually vandu we know that. Let me just refresh because your chats are coming little late. Now only I'm getting your answers. Yes. So in the holes paakumbodhu inga vandu electrons irukke, so it will move towards the side, and in the electrons paakumbodhu attract pandradhukku inga holes irukke, so it will move like this, and this will form a layer of what? It will form a layer of move பண்ணாம immobile ions வந்து இங்க accumulate ஆகும். இந்த junctionல actually வந்து immobile positive and negative ions வந்து accumulate ஆகும். And after some time what will happen basically? So இங்க இருக்கிற electrons எல்லாமே வந்து it is going towards this side, right? So again if there is any electrons wants to try to come na, this negativity will oppose. Okay, ஏன்னா electronக்கு electron பிடிக்கல. அப்படினா இங்க இருக்கிற எலக்ட்ரானோட லேயர் வந்து what it will do, it will try to, okay, it will try to oppose the flow of electrons from this n side. அப்படி வந்து பாக்கும்போது நம்ம p sideல என்ன ஆகும், இந்த இந்த p sideல இருந்து நம்ம holes will move toward this side and it will also form a layer. Okay va, and again this holes wants to come. Okay, then this layer will show some attitude, don't come, just go. Okay, just go back. So it will stop the whole flow as well. So what will basically happen da, what will basically happen, definitely we can say that definitely we can say that what there will be some sort of what to say block of, or let us say in the majority charge carriers vanda it cannot move through it. So which means majority charge carriers naala irukra flow stop aachu, which means adinaala irukra current vanda stop aachu. Okay, not clear ah? Okay, so ma'am, after NEET this week we went to trip, but during enjoyment I heard re-NEET, my heart broken, ma'am. Yes. What can be done? This we have to anyway accept, right? For same thing was happened for us also. We were also planning for something. We also got a break na. The hectic sessions ellame vandu mudichirukku, adukapram we are also planned something. Ana vandu what happened? Everyone has to come back. We got the reunion, right? Alumni. Okay. So yes. So now we were talking about P-N junction. Correct? In the P-N junction, now what will happen? In the P-N junction, eppadi form agudhu? Tell me. So inga P type, sorry, inga vandu P type irukku, inga vandu N type irukku. So in the P type la yaar irukkuda, holes dana. In the holes will try to go to the what to say electrons kitta, it will try to go. And in the electrons paakumbodhu it wants to go to the holes. So basically vandu due to this flow, okay, due to this flow in both the side la there will be a layer formed. Correct? Are you guys getting it? Where is that Mansi and Victorina, Reena, right? So I'll call you Reena. Okay, so please let me know. So appadina what will happen, inga vandu or layer form agum, and the layer la irukra positive and negative charges ku vandu it cannot move. So it will form a layer of positive ions, it will form a layer of negative ions. So this will, okay, in the layer form aanadanaala it will stop the further flow. Okay, it will stop the further flow, which means there is no current flow due to the majority charge carriers. Understood till this? Give me a heart. Understood till this? Give me a heart, everybody. So what I was saying, I was talking about the what to say, nama P-N junction da we were talking. So in the P-N junction la, okay, in the P-N junction la what is happening, there is a depletion layer will form, and the depletion layer form pannitena further vandu majority charge charge carriers cannot flow. Okay, so adinala I can say that and the majority charge carriers nala irukra current flow will stop. Idha vandu I will call it as diffusion current. What is diffusion current defined? What is diffusion current? It is due to the majority, the flow of majority charge carriers nala produce பண்ற current தான் வந்து நம்ம diffusion current. Can you define diffusion current? Okay, now suddenly I'm asking you, what is drift current? What is drift current? Everybody tell me, what is drift current? Drift current என்னன்னா, so right now we know that in the P-N junction form ஆகுற அந்த process எல்லாமே வந்து it is happening at high temperature. High temperature la what will happen? Covalent bonds will break. Covalent bonds will break na, there will be some minority charge carriers will be there in P and N side, which means P type la konjam electrons irukum, N type la konjam holes irukum. Okay, so the minority charge carriers will start flow during this time, and this is what we are calling it as drift current. Till this understood? Please give a red heart, everybody. Yes, so this is what the thing, diffusion current na due to majority charge carriers and drift current na due to the minority charge carriers. Okay, so now no boda, why da Navya, just listen here da, I'm teaching something. No, please, I don't like this, it's breaking my heart. It was very difficult. I could accept that, the re-NEET could accept panna mudiyunda, ana while I'm taking something, you people are talking something else. I don't like it. Listening, ma'am, then okay, Navya, I trust you. Okay, so now we understood about the p-n junction form. So all the values I have given. So now the thing is like ipo vanda I am making with the germanium. Okay, germanium semiconductor da I'm using. So on the germanium semiconductor use panni, if I am making a what to say, okay, if I am making a p-n junction na adula vanda when it is becoming 0.3 volt anta moment la and the depletion layer will stop the current flow. Okay va, and if I made it with the silicon now, what will happen? Silicon na definitely it will go up to 0.7 volt. Okay, till the potential difference in the depletion layer nala there will be a potential will be generated there. So adinala definitely we will be having a potential, I mean the potential across this p-n junction will be coming as 0.7 for silicon. Okay, now what I'm going to do, I'm going to do one thing. Okay, I'm going to do one thing. I'm just going to give a biasing. Biasing na I'm giving an external battery when the connect agaporum. Okay va. So now when I'm connecting an external battery over there, okay, when I'm connecting an external battery over there, I can connect in two different ways. Which means in the p-n illada, on the p side vanda I can connect it with the positive side of the battery, and n side vanda I can connect it with the negative terminal of the battery. Till this understood? Till this understood everybody? What I was talking a very simple thing. Okay, p-n junction formed. Okay, ipo vanda p-n junction diode irukke, and the p-n junction la p vanda battery oda positive terminal, n vanda battery oda negative terminal la connect pannitena, very good hero, that is going to be the forward bias. Okay, that is what the forward bias. Next one, the reverse bias, which means I will just do ulta. P type வந்து negative terminal, N type வந்து positive terminal. So அப்படினா what will happen? I have given over here. Okay, so இப்போ வந்து forward bias இல்ல definitely due to this, okay, இப்போ இந்த p-n junctionல we know that in the depletion layer நால அங்க வந்து ஒரு blockage இருக்கு, கரெக்ட்டா? So someone will come and just resolve this. Okay, அதுக்காக தான் we are introducing the battery there. So now what will happen? I have told you na germanium thukku enna and the potential barrier, what is the value, what is the potential difference across if I'm using germanium? Tell me everybody. Germanium, everybody tell me what was the potential? 0.3 volt, correct? So if I am giving a battery which is having 0.3 vida adhigama irukra potential, if I am applying na, very good hero, very good Sudarshana, very good Mansi. Yes, so now what will happen? So inga vanda if I'm giving more potential difference na, forward bias illa in the depletion layer vanda adoda width vanda reduce, it will come to thin, and suddenly there will be a rapid growth of the current, which means germanium na adoda potential barrier 0.3 da. So when the battery is also becoming 0.3, and the moment there will be a rapid growth in the current. Yeah, what is the reason? Yeah, the barrier it is gone. So definitely ipo vandu nama majority charge carriers ku vandu it can move simply. Okay va, it can move simply, so definitely no issues, the current flow will happen. And for germanium it is 0.3, that is what we are calling it as knee voltage. Okay, and the barrier potential it is overcoming. Okay va, so the knee voltage, when it is reaches the knee voltage na, definitely the current flow will happen, and that will be in milliampere. Note panniko, that will be in milliampere. Understood everybody? Understood? Yes or no? Now we can go for the reverse bias. So in the reverse bias what will happen? Definitely idoda ulta tha it is going to happen. So reverse bias la vanda potential barrier, I mean adu vandu adoda width vandu increase agum, and of course we know that na silicon is 0.7. Yes Mansi. Okay, so now in the reverse bias la, due to, I mean in the potential difference vandu same direction la tha irukku. So in the depletion layer oda barrier vandu increase and up to, I mean ellathukkume oru limit illada. So idukku kuda oru limit irukku, and the limit break aachuna, okay, if you cross the limit na, what will happen? And the diode vanda it will get damaged. Simple. Okay, ipo vanda and the limit vida it is going more na, what will happen? Idu vanda damage agum. So now we can say that nama reverse bias illa depletion layer oda width will increase, and suddenly it will break, and there will be a rapid current flow which is in microampere, okay, which is in microampere, and due to that I will call that particular voltage as breakdown voltage. What is the meaning? Sorry, what is the name? It is nothing but the breakdown voltage. What is breakdown voltage? We will give the reverse bias potential. It will increase at some time. What will happen? And the junction one, it will break down. That's the breakdown voltage. And for germanium, it will be 25 volt, and for silicon, it will be 35 volt. Purinjadada everybody, yes or no? Yes or no? So, knee voltage, na, what is the meaning? When it is in forward bias, the depletion layer will become thin and motion, then we will say knee voltage. And when I'm talking about breakdown voltage, that is happening in the reverse bias condition, and in the reverse bias definitely what will happen? On the potential increase a depletion layer or a width could increase at some point it will break down, and there will be a rapid current flow which is in microampere. Don't mistake, here it will be milliampere, here it will be microampere. Let me know, everybody, yes or no, yes or no. Okay, so now Binti, what is Binti? I don't know. Hello? Same issue. What should I do? Video capture device.
And above you can see activate, deactivate, something is mentioned.
Nothing is coming. Okay.
Deactivate.
Deactivate.
Deactivate and click on activate again.
Okay. Yeah. Thank you. Thank you. Yeah.
Oh,
So guys, am I visible? Yes or no? Done? Is it everything okay? Give me a thumbs up if everything is fine. Yes, 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 yes. Thank you. Thank you so much, guys. Thank you so much. Yes, just give me a second. Yes. Let us continue now. Okay. So what is the problems? What are the things happening around me? So I don't know. So yes, P-N Junction we have discussed. So now the thing is like we are going for the Zener breakdown. Okay, Zener breakdown. What is Zener breakdown? So actually this is actually happening in the reverse bias condition lata. Okay, yes da avalanche breakdown also we'll discuss. Okay, so this is what our Zener breakdown. This color is visible. Yes, this is what our avalanche breakdown. So when I'm talking about Zener breakdown, we know that this is happening in the high reverse bias voltage. Okay, so just note panikoda. High reverse bias lata, this is happening. Zener breakdown it is happening at the high reverse bias. Ana the avalanche breakdown is also happening in very high. Okay, so idha vida adhigama irukkanum, very high voltage. Okay, wow. This is happening in the very high voltage. Maybe device got heated, ma'am. I don't know. Okay, let us see. I think there won't be much issues will come. So next one, in the Zener breakdown, covalent bonds of the depletion layer break due to the high electric field. Ana the avalanche breakdown it is because of the minority charge carriers or the collision in the covalent breaking is happening. Okay, so both the cases the covalent breakdown da. Ana yes, don't worry, we will do. Okay, so right now Zener breakdown na adu high reverse bias illa, adavida high reverse bias illa the avalanche breakdown will happen. And also Zener diode paakumbodhu we can say that, okay, hey, we can just discuss this cutoff and everything later da. Let me finish this. It's already 8 o'clock. In 30 minutes I need to finish this. Okay, so let us see. Okay, hoping for the best. So, the covalent bond breakage is happening due to strong electric field. Ana avalanche breakdown it is due to the collision of minority charge carriers. Purinjidada everybody? Everybody understood? Yes or no? So, this is the first point. And the Zener diode, Zener breakdown is happening in the high doping case. Okay, so Zener breakdown is happening in the high doping. Ana avalanche is happening in the low doping. Both the cases covalent bonds oda breakage da. Ana idhila strong electric field. Ana here it is due to the collision of minority charge carriers. Now in the case depletion layer thin irukum. Okay, depletion layer it is thin. Ana here it will be thick. This is the major difference you should study when it comes to Zener and the avalanche breakdown. Understood till this everybody? Yes, we will try to do the questions also. No worries. Okay, wow. Okay, yes or no? Yes or no? 1 second. Yes. So now in the Madre we should study about this Zener diode as well. Zener diode na a device which is working in the this breakdown region. Okay, it is nothing but Zener diode is working under the reverse bias breakdown region la da adu work aga pore. So in the Zener diode paakumbodhu we know that high voltage, high reverse bias when it comes to now, it will be get damaged. Ana when the Zener diode, due to this high doping nala, it won't be get damaged. Okay, it won't be get damaged. Purinjidada? So Zener diode advantage enna, whatever be the current flowing through the circuit, eppavume across the Zener diode, it will maintain a constant potential. What is the potential of the Zener diode? Eppavume you can trust the Zener diode. You can connect the Zener diode with the device. So always on the device in the Zener diode voltage da kadakaporo. Whatever be the voltage. Okay, whatever be the rest of the circuit, whatever be the voltage coming, ana in the device eppavume in the Zener diode voltage da kadakaporo. Yes, Lakshmi, logic gates we will finish, no worries. Understood, yes or no? Next one, the another device is the light emitting diode. Okay, so now when I'm talking about this light emitting diode, it is actually working in the forward bias P-N junction. Okay, forward bias P-N junction. LED na light emitting da. Okay, wow. So it is actually something like light emitting diode da. So definitely what will happen, the N side la irukra electrons and nama P side la irukra holes ellame vandu, we know that they will recombine. So on the point la there will be a what is the energy of, or let's say there will be a release of energy, and the energy release will be in the form of photons. So over photon ode energy illana frequency depend panni, we know that there will be a there will be a what to say in the what to say nama photon oda frequency depend panni light vandu different ah irukum. So we can produce different types of colors of LEDs. Purinjadada? So we know that light emitting diode is actually working in the forward bias condition, and also we know that when the recombination of electron hole pair formed, during that time it will release some energy, and the energy is in the form of photons da. Over photon ode frequency illana wavelength depend panni different colors we will get. Got it? So now next one vandu photodiode da. Photodiode is actually working in the what is a reverse bias condition la da, it is actually working nama photodiode. And also nama photodiode la you can see that photons hit on the junction. Okay, photons will hit in the junction, creating electron hole pair. Okay va? So ovvaru electron hole kume vande energy kadike porom, so it will form a or let's say it will creating electron hole pairs. So the thing is like if there is no light falling on the junction, okay, so in the photodiode as actually working when the light is falling on the device. Are you guys getting it? When the light falls, this will activate. So if there is no light now, what will happen? There will be a small current due to minority charge carriers. Okay, we know that now, idu vandu reverse bias la. Are you guys getting it da? Yes or no? Can you just respond? Yes or no? So LED na simple da irukke, forward bias la it is working, and it will release light, or let's say it is releasing the photons. Correct? And now when it comes to photodiode, reverse bias la da work panirukke. Okay, and we know that when the light falls, what will happen? This will be creating electron hole pairs. So when there is no light, anga vandu minority charge carriers nala microampere la there will be a very small current. Ana vandu when light falls, electron hole pair will be more, and the current flow will also going to be more. Okay, and எப்பவுமே வந்து இந்த photodiode பேசும்போது அந்த current will be எப்பவுமே proportional to the intensity of light தான். So இந்த photodiode சொல்லும்போது you should specify the light with suitable frequency. நம்ம dual natureல சொல்ல மாதிரி, நம்ம photoelectric effect சொன்ன மாதிரி இங்க கூட you have to specify light with suitable frequency falls on the photodiode. அந்த photodiodeல when it is falls na அந்த momentல it will be producing electron hole pairs. So this current will increase. So we will be getting the photodiode. Next வந்து நம்ம solar cell da. Solar cell is actually working like the photodiode. ஆனா வந்து external biasing எதுவும் தேவையில்லை. Okay, in the solar cell we don't need any external biasing. It is just sunlight வந்து directa it will fall on the P-N junction, and that will be converted as the EMF. இல்லனா voltage இது வந்து convert ஆகும். That is how it is working in the solar cell எல்லாமே வந்து it is working like this. Understood? Everybody got it? So இதுல வந்து 3 process இருக்கு solar cell ல. அவ்ளோ you don't need it. Generation இருக்கு, separation இருக்கு, So in the generation of electron hole pairs when the light is falling on it, separation in the electric field will be formed, no? So at the time in the electron and holes separated agum, and then the collection, the electrons will be reaching to n side and the holes will be reaching to p side. So this is how the positive and negative terminal, illana positive and negative or higher or lower potential is created. Okay, so these three devices you have to study. So now I think it is the turn for rectifier. Okay, so when we are talking about rectifier, we have two types of rectifier, correct? So what are the two types of rectifier? Half wave rectifier irukke, full wave rectifier irukke. So when I'm talking about half wave rectifier, we know half da ipo vandu input compare பண்ணும்போது output la we will be get exactly the half of it. So let us say இது வந்து ஒரு transformer da, இந்த transformer la we will be giving the input la we can see positive and negative cycle irukke. And why we are using this rectifier? Can you give me the answer? Can you give me the answer? Definitely da, just let us just finish this, adukapra we are going for it. Okay, no worries. I will be doing at least few 5-6 questions vandu we can do it today. I have kept many questions, but as per the time we can. Okay, no worries. Okay, so yes, input equal to output no da, no, frequency vandu same da. Okay, so nama input, why we are using the rectifier? Tell me the answer. Rectifier edukaga we are using? Rectifier vandu actually vandu AC vandu we are getting AC, ana vandu enakku vandu DC kadaikanum. Appadina I can use the rectifier to convert AC to DC. Idhula vandu paathena inda diode ku oru property irukku. It is unidirectional. Ore oru direction la irukra current mattum da adanal vandu pass panna mudiyum. So adanal and what is and the quality illa and the advantage use panni da we are just going for this what is a rectifier which is used to convert AC into DC. So இப்போ வந்து half wave rectifier சொல்லும்போது we know that இங்க ஒரு transformer இருக்கு. இதுல primaryல we will be giving the input. So in the inputல outputல we have consider a diode and also the external device is also there. Now what happens? We know that when the positive cycle comes, okay, when the positive cycle comes, we know that right now this is in forward biased condition. Of course, we will be getting the input. Now the negative cycle comes. In the negative cycle, what will happen? In the negative cycle, what will happen? Now it becomes in the reverse bias. So we won't get any kind of output. Again, positive cycle comes now, what will happen? Again we will be getting the positive thing. Got it, everybody? Got it? Yes, Henid Maria, after this session, comment box la, description box la ella ellume irukum. Illana ipo vandu inda crash course la join pannitena app la you will be getting directly. Okay, so positive cycle ku vandu you will get a output, ana vandu negative cycle ku you won't be getting it. So that is why we are calling it as the half wave rectifier. Okay va, so here we will be getting, okay, ipo vandu initial in the input la irundha negative cycles ellame vandu cancel agum. We will be getting only in the positive half cycle oda output mattum da we will get. Now we have the full wave rectifier. Full wave rectifier la we will be having two diodes and we will be using a center tapped, okay, we will be using a center tapped transformer. Why we are using center tapped transformer? Why we are using? Tell me, everybody. Everybody tell me. Why we are using center tapped? Yena vandu we need to switch, we need to flip the input. Correct? Which means we know that when I'm talking about input, first vandu positive half cycle da. So let me just say, inga vandu A irukke, inga vandu B irukke. So for according to A, this is in the forward bias condition, it will give you a output. Okay, it will give you a output. So which means let it be there. Now what will happen on the same positive half cycle when it comes to B? In the center tapped nala idu vandu flip agum, which means in the positive half cycle will become negative for the point B, which means 180 degree flip irukum. Now look at this figure. Idu vandu reverse bias la irukke, no input, sorry, no output. So for this is what happening for A, this is what happening for B. So inga vandu paathena idu vandu negative half cycle la irukke, and for B la irukra diode ku vandu idu vandu reverse bias da. So this won't be giving any output. So we got, okay, the first positive half cycle nala you got this output. next one, what is happening? Next one, the number negative half cycle da. We have the negative half cycle. What will happen at A? Tell me. So ipo vanda in the negative, in the point A ila nama first negative half da vandirukke. Correct ah? Appadina and the D1 vanda forward ah illa reverse bias ada. Forward bias or reverse bias. Quickly let me know. Quickly let me know. So in the point A ila forward bias ah illa reverse bias ah. Negative cycle da. Negative cycle சொல்லும்போது very good Dr. Mansi. Same Mansi? Okay. So this will be reverse bias. So this is not going to, okay, in the negative cycle, this is not going to give any output. Ana, we have used center tapped, correct? Center tapped transformer. Appadina what will happen da? Inga vandu 180 degree flip nala, now B ki vandu we got a positive half cycle. Appadina what is the output from B? And the D2 la, it is going to be reverse or forward. F or R. Tell me, F or R. What will happen? So right now B la vanda and the negative half cycle become positive. So this becomes forward bias. So you will be getting the output. So now we are getting the output. So basically vandu sollumbodhu very good forward, very good. So basically vandu sollumbodhu whatever be the input you have given adukkaga equivalent ana DC vandu you will be getting it. Purinjudada? Everybody got it? So this is how the half wave and full wave rectifier works. And half wave la input frequency and output frequency vandu same da. Ana in the full wave rectifier la output frequency ingirada 2 times the input frequency da. Okay? And still looking at the diagram we know that again ripples irukke. And the AC ripples irukke. Correct? So adukkaga we can use filters. Okay? We can use filters to remove the, why we are using filters? Why we are using the filters? Tell me, everybody. Why we are using the filters? We need to remove the we need to remove the ripples. Correct? AC ripples வந்து remove பண்றதுக்கு தான் we are actually using this. So அதுக்காக we can use a capacitor parallel to the device connected na இது வந்து reduce பண்ணலாம். இல்லனா ஒரு inductor capacitor combination வந்து we can use it. இல்லனா pi filter na இப்படி இருக்கும். Okay, so இப்படி வந்து நம்ம capacitor, இங்க வந்து inductor, and here we will be having another capacitor. This is what the pi filter. This is what the most, okay, this will remove almost the ripples from here. Okay, so this is what we need to study. Now let me go for the logic gates also. Adikapram we can just go for, or should we practice some questions for 10 minutes? Adikapram can we start this thing, logic gates, yes or no? Ripples na the shape illada. So actually வந்து DC na இப்படி இருக்கணும். கரெக்ட்டா? ஆனா வந்து பாக்கும்போது what is happening? இந்த மாதிரி தானா? That is what AC ripples. Okay, ripple மாதிரி. Questions or logic gates? Let me just check for the votes. Okay, questions na red heart and nama what is the rest? Logic gates na yellow heart. Is it both? Okay, red heart for questions, yellow heart for logic gates. Let me see. Red heart for, I will write because I'm just forgetting this. Red heart for questions, yellow heart for what? The logic gates. Oh my god, because it's been 9-10 days. These long sessions I was not taking. I think more with the same people are doing it. That I won't allow. Only one time. Hey, now yellow is leading. Hey, one time only it is possible. Don't do unfair things, okay? Okay, let us do one thing. Hey. So இது வந்து டஃப்பா இருக்கேன்டா. எக்ஸாம் வந்து இது விட ஈஸியா இருந்துருச்சு. இது வந்து how I'll get to know. Okay, so let us do 2 questions. Okay, அதுக்கப்புறம் பார்க்கலாம். Okay வா? And again, one more important relation I forgot to teach. நம்ம mass action law. இது வந்து beginningல I have to. Mass action law. What is mass action law? Give me the answer. Quickly. Mass action law. NE into NH, which will be equal to Ni square. What is Ne? What is NH? What is Ni? Ne na concentration of electrons. What is H? Concentration of holes. And what is Ni? It is nothing but the concentration of intrinsic semiconductor. Okay, wow. So recombination. Okay, so this is what the mass action law. Okay, this is based on this we can expect some questions also. Now let us quickly go for a very simple question. Very simple question. Okay, the questions one the quicker we can do it. 5 minutes la 5 questions. Done? Ready? The intrinsic semiconductor becomes an insulator. Give me the answer. Give me the answer. Give me the answer. Give me the answer. Very good, very good. No. Very wrong, very wrong. It is at 0 Kelvin, not at degree Celsius. Okay. Intrinsic semiconductor become an insulator at 0 Kelvin, not at 0 degree. Okay. So now let us go for the next question. Yes. Another question. Give me the answer quickly. Everybody give me the answer. In semiconductor materials, the mobilities of electrons and holes are mu E and mu H. Which of the following is true? Mobilities of electron and holes. Give me. Give me the answer. Give me the answer. Give me the answer. Give me the answer. What is the answer? Okay, I'll move from here. C wrong, C wrong, C wrong. Don't give me C. Don't give me C. It is wrong. You will feel like இது வந்து what is it? நம்ம mobility வந்து same ஆகும். அந்த மாதிரி தான் you will feel. ஆனாலும் just think about that. So நம்ம electrons வந்து எப்பவுமே conduction bandல தான் and holes வந்து valence bandல தான். So conduction bandனா கொஞ்சம் freed அங்க இருக்கும். Okay, so it is something like you are with your family and friends. So friends கூட we will be very you will be having more freedom, right? Okay, so ana vandu family kuda it is a little bit strictness will be there. So adinala we can say that the mobility of electrons will be higher than that of the holes. Yena vandu electrons vandu conduction band la da, holes vandu nama what to say valence band la da. Okay, wow. So now quickly we are going for the next question. Quickly give me the answer. A silicon specimen is made into a p-type semiconductor by doping an average 1 indium per 5 into 10 to the power silicon atoms. Okay, so இப்போ வந்து இந்த doping எல்லாமே பண்ணும்போது we cannot just randomly give. Okay, one siliconக்கு one impurity அப்படி இல்லடா, இவ்வளோ number of siliconக்கு வந்து you can add one impurity அப்படி இதா இருக்கும். Okay, so இப்போ வந்து இந்த questionல 5 into 10 to the power 7 siliconக்கு வந்து one impurity தான் add பண்ண முடியும். Got it? The first line. Now, if the number density of the atoms in the silicon is 5 into 10 to the power 28. Okay. So, if what you understood, right now, nama kaila 5 into 10 to the power 28. Correct? 10 to the power 28 atoms of silicon irike. Appadina, what is going to be the number of acceptor atoms? This is simple. Okay. So, 5 into 10 to the power silicon is 1 impurity. Right now, how many we have? 5 into 10 to the power 28. Appadina, what is going to be? How many number of impurities we need to add? Tell me quickly, everybody. Everybody, let me just... Everybody. Quicker, you can give me the answer, da. Simple ana concept. 5 into 10 to the power 7 க்கு வந்து 1. இப்போ வந்து நமக்கிட்ட 5 into 10 to the power 28 இருக்கு. So அதுக்கு வந்து how many impurities we need to add? How we will be doing it? How we will be doing it? Very simple da. So we know 5 into 10 to the power 7 க்கு வந்து 1. Now I have 5 into 10 to the power 28. So appadina I can just divide it with 5 into 10 to the power 7, which is going to give me 5 into 10 to the power 21 as the number of acceptor atoms. Ana vandu nama options vandu paakumbodhu it is actually given in centimeter cube. Idu vandu meter cube la da irukke. Okay va, this is actually in meter cube. So you need to convert into centimeter cube. So while we are converting into centimeter cube, what you will be getting? You will be getting option C as the answer. Purinjidada everybody? Yes or no, yes or no, yes or no. Give me a red heart if you understood. Yes or no. Are you guys getting it? See the right answer. Very good, very good, very good. இது வந்து இப்போ வந்து per meter cube na நம்ம answer வர போறது into 10 to the power 21. ஆனா வந்து we should go for the what to say per centimeter cube தான் நம்ம வந்து பண்ண போறோம். So now let me just take some circuit problem. No circuits ah. Why? In the questions எல்லாமே வந்து you guys have to do, okay? Figure shows a diode connected to an external resistance 100 ohm and an EMF. Assuming that the barrier potential developed here is 0.5, obtain the value of current in the circuit. So இது வந்து 0.5 தான். ஓகேவா? இது வந்து 0.5 தான். இது வந்து this is the positive side, this is the negative side, which means forward biasல தான் இருக்கு. Okay, this is actually, ma'am, number 5 will be there. What number 5? Did I miss anything? Maybe. I didn't get you to love learning. What happened? Okay, so இப்போ வந்து பார்த்தேன்னா இது வந்து forward biasல தான் இருக்க போறோம் and we need to find the current. Current ஓட equation என்னடா? It is nothing but V by R da. So there is no confusion in R. That is nothing but 100 ohm. Now it is the turn for V. What is V? Quickly tell me what is V. What is V? Everybody quickly tell me what is the value of V. Forward biasல தான் இருக்கு. So 4.5 இருக்கு, 0.5 இருக்கு. So அப்படினா what is going to be that? It will be nothing but 4. 4.5 minus 0.5. ஏனா hey 5 அது வந்து reverse bias ஆகும்போது தான் நம்ம potential வந்து increase ஆகும். கரெக்ட்டா? So forward bias na what to say நம்ம potential இல்லனா electric field due to the P-N junction will be in this direction and நம்ம biasing la இப்படி தான் I mean we will do it. So which means it will subtract. Yes, very good. So now let us do one more question. One more. Yes. Another question. What is the value of current I in the given circuit? In the I da nama vandu find pananum. Can you find it? Exactly the same. Okay da. Okay. Maybe I have made the mistake. Okay, I think it is sorted, right? Love learning. So now if the question was the same as the previous question, I think it is visible right now. Correct? Okay, so now you just do it. Everybody do it. Same, exactly the similar question. 2.7 volt da external battery, 0.7 for silicon, 0.3 for germanium, and what is the current? This is the question. Okay, so when I'm talking about current, what is the equation? Current or equation என்னடா? V by R. So in the case lo kuda R ku vandu confusion illa 1 kilo ohm da, so I'll be writing 1000 ohm. Now the thing is like V. What is going to be V? So V vandu paakumbodhu we know that idu vandu forward bias la da. Correcta? Idu vandu positive terminal da and that is connected with the positive terminal of battery. It is in the forward bias. Ana idu vandu reverse bias la da. Correct? This is actually in the reverse bias condition. So in the reverse bias, there won't be any current flow. So you can just ignore this. Why? ஏனா reverse bias அங்க வந்து இது வந்து diode இல்லையாடா. So reverse bias current flow will not happen. So அதனால you can just split, I mean you can just remove this. Now the circuit becomes even more easy. Okay, so now the circuit la vanda we will be having one diode over here and that is what 0.7. This is what our 2.7. Idu vanda forward bias la da. So what is going to be the potential? What is going to be the potential? Quickly give me the answer. Quickly. Similar to the previous question. Forward bias na what will happen? Forward bias na what will happen? Everybody. Forward bias la what will happen? Very good. So this will become 2.7 minus 0.7. Okay, so you will be getting 2 by 1000, which is means option A will be the right answer. Understood everybody? Give me a red heart if you understood. Everybody. How 4? How you guys are getting 4? 2.7 minus 0.7 lada. So you will be getting 2 divided by 1000. So 2 milliampere. Done. Thank you so much for the hearts, da. Thank you so much. Now let us go for the Zener Diode question someone has asked. No. Zener diode. Oh my god. Yes, Zener diode. So, Zener diode, who was asking Zener diode? Yes. Kakashi, right? If I'm pronouncing it wrong, please correct me. Okay. So, now Zener, so in the question, what is given? In the following circuit, what is the current flowing through 1 kilo ohm resistor if the Zener breakdown is 5 volt? Okay, Zener breakdown when the 5 volt and they have given. Now you have to find the current flowing through 1 kilo ohm. So, very simple question. How we will be doing it? What is Zener diode? What we have mentioned? In the Zener diode, what is the use of it? We are using it as a voltage regulator. Am I right or wrong? We are using it as a voltage regulator. Appadina and the device, okay, appadina and the device, what is the across the same potential. Whatever be the potential you are giving over here and all, it is not at all matter. If you use the what is a Zener diode na, and the device எப்பவுமே கடக்க போற potential it is nothing but 5 volt da. Got it? So now the question is, what is the current? Current will be, we know that V by R da. So in the case V na 5 da, R na 1000 da. Simple. Understood? Yes or no? Yes or no? Yes or no? Are you guys getting it? Are you guys getting it? Yes or no da? Very good, very good. Answer one the A da. Understood? Please give me a red heart, everybody. Very good, very good. So I think now we can just go for the, what is the logic gates. Okay. Shall we go for logic gates? Ready? Yes, exactly. So now we are going for the, again, I have added more circuit problems and everything. Right now we don't have the time. So let us do it later. So first one, nama OR gate da. So OR gate, why not 500 ohms? What is asked? What is in the question? And the 1 kilo ohm current da. Adula vandu pass pandra current da, we need it. Got it? So anta current vandu paakumbodhu, you should know the current flowing in it, and you should know the resistance, and you should know the potential. Potential la confusion e kedaiyadu. Adukku across vandu eppovume nama Zener diode oda potential da. Okay va? Got it? Purinjuda? So now the thing is like, you got the potential, and the potential divided by, potential divided by resistance. So whichever be the resistance asked in the question, and the resistance mark pandiko, that's it. Got it. Fine. Okay. So now nama OR gate da. OR gate na idilla na adu. Appadida. Okay. So 0 0 varumbodhu 0 da. Ana vandu 0 1 vandena, you should go for 1. Okay va? And also 1 0 if I am giving. Okay. First one, let me just start with the NOT gate. That will be better. Okay. So first one, let me go for the NOT gate. So what is NOT gate? So ippadida we will represent. Okay. So the one, I will give an input and I will be getting the output. Input na A, the output na A bar da. Now give me da. Ipo 0 da I am giving. What is the output? What is the output? Can you just let me know? What is the output? Ipo 0 if I am giving na, what is the output? Concept, you guys don't want the concept for logic gates. Can we go for the questions directly? Is it fine for everyone? Very good, Maha. It is actually coming as 1. If I am giving 1, I will be getting the output as 0. So this is what our NOT gate. Now let me go for the OR gate. OR gate na ippadida irukum. Okay, ippadida it will be there. So we have to give 2 inputs. Okay, we have to give 2 inputs, and you will be getting the output as A plus B. So if I am giving 0 0, what is going to be A plus B? 0 plus 0, 0. 0 1 na 1, 1 0 na 1, 1 1 na 2. It is not possible. We will go for the maximum. So we will be getting 1. Everybody understood? Yes or no? Give me a red heart, everybody. In the OR gate, if you understood, na, give me a red heart. Simple da irukke. Next idoda NOR gate da. NOR gate na ennada? NOR gate na simple da. So in the OR gate la I will add a note, which means inga vanda output A plus B dana, you got it. Now I am telling you this is coming as A plus B bar. A plus B bar na enna? Ipo vanda inga vanda you got 0. Appadina in the NOR gate la A plus B bar da. So can you just give me the answers? Just quickly you give. What is the answer? 0 1 0 1 0 1 or 1 0 1 0. So 4 digit you give. Everybody. application of logic gates na, let us say what is it ipo vandu sometimes we know that what to say in the let us say it's not coming, yeah, ground floor la you have some switch, on the first floor la kuda you will be having some switches. Okay, so right now the thing is like, you know that you will be putting the fan from the ground floor. Ana vanda when you just thought about, you are in the first floor and you thought that okay, I forgot to switch off the fan, but that switch will be there. Okay, so you can just switch it off from the ground floor. So that is what the logic operation. And also you know that the light which we are using outside, no, so adukku vanda there will be a switch outside as well as nama inside house kulla kuda one more switch irukum. So idudha vanda application. Very good, very good. Idoda note enna 1000 da. Okay, next vanda nama AND gate da. AND gate சொல்லும்போது இப்படி தான் இருக்கும். Okay, AND gate இதுக்கு கூட A B இருக்கும். Output என்னன்னா A into B தான், multiply பண்ணணும். So 0 0 na what will happen? 0 1 0 0 1 1 1. Can you give me the answer? Can you quickly give me the answer, everybody? What is going to be the output for this one? 1 into 0 0 0 into 1 0 1 into 1 will become 1. Next வந்து நம்ம NAND gate தான். NAND gate na what is happening? In the AND gate la I will be adding NOT gate, which means idoda output vandu A into B NOT. Got it? Appadina what is the output? Can you give me the output? Already I got the outputs. Very good, very good, very good. What is going to be the output for this one? What is going to be the output for this one? It is nothing but 1 1 1 0. Till this understood now? Everybody give me a heart. Everybody give me a heart. In the gates ellame vandu purinjiduchuna, give me a heart. Everybody, gates ellame vandu important. Yes, very good, very good. So ipo vandu we just need to study some more da. Okay, yes, this also you need to study. Yena vandu problems ellame varumbodhu easier you can just crack it. So let us say ipo vandu in the what to say you need NOT gate from AND gate. Okay, so you have a NAND gate adilirundu, yena in the NAND and NOR gate is known as the universal gates. Yena and the two gates irunda podum you can create all the rest of the gates. Okay, so understand NAND gate and NOR gate is known as the what? Universal gates. Universal gates na Nikita, already some sessions are scheduled. You can just go for the live sessions. You can see it. Okay. And also, adla vandu konjam change irukum in some, I mean, day after tomorrow or after that, I will go for a marathon session. So, it is not required so far. Yena vandu nama syllabus paakumbodhu they have specified OR gate, NOT gate, NOR gate, NAND gate, and this is not what is it mentioned. Okay, so right now, so adu vandu if you have done with everything, ellame finish aachu, adukapram yes I have extra time, then you can go for that and all. Okay, right now I won't be going for that because syllabus illa direct specify pannala. Right now I'm just sticking with the things which is directly mentioned in the syllabus. Yena vandu first we have to give the priority with that. No, so now the thing is like, if you need to make NOT gate from NAND gate na, okay, NOT gate from NAND gate na, what we can do, you can give the same input. Okay, same will happen for the NOR as well. So NOR la kuda if you need to find or if you need to make NOT gate na, you can just give the same input. So note panniko, whether it is NOR gate, whether it is NAND gate, you need NOT from it. Appadina you should give the same input. Understood? Understood everybody? Yes or no? Gausika, you just go back and you can just watch it again. Okay, you will get to know. Simple da irukke. Very simple. If you know adding, if you know multiplication, that's it. That is what NOR and NAND gate. Okay, so now if you need to, okay, if you need to get NOT gate from NOR gate or NAND gate, you should give the same input. You should give the same input, then definitely you will get it. And now another thing is like, in the NAND gate larunda you need AND gate. Okay va? NAND gate larunda you should get the AND gate. Appadina universal gate na, it can, I mean, all the rest of the gates vandu idile irundhu we can take it. Okay, you don't need specifically NOT gate, AND gate, no, OR gate. If you have NAND gate, you can do everything from it. You can create all the gates from it. That is why it is known as universal. Okay, so now ipo vanda in the NAND gate la irundhu you need AND gate na, adukku vandu you should take two NAND gates. Okay va? Got it? இப்போ வந்து what I'm saying, NAND gate ல இருந்து you need AND gate. Okay, so அதுக்காக how many what is a NAND gate required? 2. Exactly the similar way, if you need what is a OR gate from NOR gate, how many diodes how many what is a NOR gates you required? இன்னும் 20 minutes da, hardly வந்து 20 minutes. Okay, so tell me how many NOR gates required to produce OR gate? Same, 2 da. Understood? Very good. So this is how we will be doing it. We will give different output. Ana and the second NAND ku vandu you will be giving the same input na, you will be getting the AND gate. And now OR gate and NAND gate adoda combination. In the NAND gate use panni you need OR gate na, you should go for this construction. Okay, the first 2 gates ku vandu you will give the same input. Adukapram you will be giving the 2 outputs you got it from the first one to the third one. Okay, so இது வந்து initially வந்து புரியறதுக்கு கொஞ்சம் கஷ்டமா இருக்கும். ஆனாலும் after this session in the notes வந்து you will get na, அந்த டைம்ல just go through it, draw the diagram and try to find the final outputs. You will be getting it. Okay, so this is what we need to study. Now let us just go for 1 or 2 questions, then we can just wind up. Okay, so இது வந்து ஈஸியா தான் இருக்கு. This is easy. This is easy. Everybody tell me the answer for this one. Notes வந்து class முடிச்சதுக்கு அப்புறம் தாண்டா you will get. So quickly give me the answer for this question. ஏனா வந்து we already discussed about this. Everybody, what it is representing, can you please let me know? இங்க வந்து 2 OR gates இருக்கு, ரைட்டா? 2 OR gates இருக்கு. Okay, 2 NOR gates இருக்கு. So இதில இருந்து you need to get what? You just give me what is the output. We already discussed about this. இதோட output என்ன ஆகும்? What we have discussed. We just now only we have discussed about this, right? இது வந்து nothing but OR gate from the NOR gate. So in the construction la, what you will be getting? If you have confusion, no worries. Take your time, take the table, write all the values and try it. You will be getting the same one. Got it? So what I'm doing here, I'll explain this. Okay, you just see here. So now the thing is like I'm giving the output as 0, 0, sorry, input as 0, 0. So இது வந்து ஒரு NOR gate தானா. What is the output? If I'm giving 0, 0, what is the output? Tell me. NOR gate. NOR gate na first வந்து you should find A plus B. அதோட note தான் வந்து நம்ம answer. Correct அல்லடா? So அதனால I can say that 0 plus 0 will be coming as 0. அதோட note na நம்ம output இங்க வரது வந்து 1 தான். Okay. ஆனா வந்து we know here also I'm giving 1, here also I'm giving 1. Okay, input வந்து same இருக்கே. So 1 plus 1 வந்து 1 தான். அதோட note வந்து 0 தான். Understood? Give me a red heart everybody. Give me a red heart everybody if you understood. Very good, very good, very good. So 1 plus 1 na 1 it will come. அதோட note value. Got it? Yes or no? Still confusing? Yes or no? Yes or no? Okay, so now under I'm just doing another one. I'm just taking 1 1. Okay, let me go for 1 1. So 1 plus 1 na என்னடா 1 தான். 1 ஓட note, ஏனா இது வந்து ஒரு NOR gate தான். So 1 ஓட note na 0 தான். So which means இங்க வந்து input வரது வந்து 0 0 தான். So when I'm coming, when it is coming 0 0, 0 plus 0 0. அதோட note value which is again coming as 1. Okay, so 0 0 வரும்போது we got it as 0, 1 1 வரும்போது we got it as 1. So which means hence we can say option B will be the right answer. So இதுல வந்து you just need to do the last one only. ஏனா we can see that the last one ல மட்டும் தான் அந்த final answer change ஆருக்கு. So you can just go for option B. Got it? Okay. So now let us go for the another question. Okay, so in the question la we can see 2 NAND gates இருக்கு, 1 NOR gate இருக்கு, 1 OR gate இருக்கு. Okay va? So this is what the thing. Now tell me what is going to be the answer for this? What is going to be the output? Okay, what is going to be the output? இதுதான் வந்து we need to find it. Can you find it? Can you find it? So what is the output from this one? What is the output from this one? We know it. Creating NOT gate from NAND gate. So this is nothing but A bar. This is going to be B bar. Now I'm just going to modify this. Just try to understand. Here is our A bar. Here is our B bar. Okay. So tell me what is the output? What is the output? A bar, B bar. So I'll getting A bar plus B bar, the whole bar. What is the output? If I'm writing A bar plus B bar, the whole bar, now what is going to be the answer? What is going to be the answer? It is nothing but A bar plus, multiplied by B bar. So I'm getting AB. Okay. Now the thing is like here we have a OR gate. So this is nothing but AB, and again one more connection is there, that is nothing but B. Okay va? So now you should find the output Y. Now you should find Y. So what is going to be Y? What is going to be Y? You need to add. So A dot B plus B. Correct? So now what you can do? You can just take B outside. Yeah, on the same result we cannot get it, right? So I'm just going to do one thing. I'm just taking B outside. So I'll be getting A plus 1. Till this understood, everybody? Till this understood? Yes or no? We will be getting A plus 1, which is equal to B. Now my question is, okay, just focus here, da? Just focus. What I said, B into A plus 1 I'm getting. Correct? I'm getting A plus 1 into B. Now you just tell me in the A plus 1. Okay, A plus 1. இதுக்கு வந்து 2 chances தான் இருக்கு. Correct? Either A can be 0 or A can be 1. Am I right or wrong? In the A value வந்து it can be 0 or it can be 1. அப்படினா பாக்கும்போது if I'm giving 0 plus 1, I'll be getting 1. If I'm giving 1, again I'll be getting 1. So what is the result of A plus 1? What is the result of A plus 1? Even if it is A is 0 or 1, whatever it may be, what is going to be this A plus 1 value? It is always going to be 1. We have the proof here. Are you guys getting it? Okay. So now we understood A plus 1 into B da. So idhula vanda A plus 1 paathena, idukku vanda A ku possible ah irukra values vanda either 0 or 1. We don't have any other value, right? So eppovume vanda we understood A plus B vanda eppovume 1 ah irukum. Appadina I can say that B into 1, so the final result will be B. Can you give me a red heart if you understood? Everybody, yes, Pujari, right? Yes. Preeti or Pujari? So this is nothing but, oh my god, it's a long name. Pujari, Preeti, Sri Lakshmi Devi. What is your actual name? Okay, so this is what we need to understand from the logic gates. So those are feeling little difficult, na? All the circuit diagrams you have to take. Adukapra you have to find the answer for it, then go for it. Okay ba? Illana nama short nama semiconductor oda oru small session irukku, adu vandu paathalu podum. Okay, so இப்போ வந்து difficult na நீங்க வந்து இந்த logic gates touch பண்ணல, அப்படிதான் இருக்கும். Okay வா? So right, do one thing, whatever be the things we have done, அதுல வந்து just try to, okay, it will take some time, ஆனாலும் பரவாயில்லடா, give some input, அதுக்கப்புறம் what is the output, you just check it and then check with the verify with the answer. Okay, understood. Okay, so now we are winding up this session and I just wanted to know the feedback about the class after this. I will check the comment box. So as always, I wanted to be happy after the class. I will just after the class I will read your comments. So I wanted to know how was the class and what is your expectations. Do we need to do something else? Yena vanthu we too don't have a clarity. Like the students want concept clarity, illana question practice. Please let us know in the comment box. We will definitely change the schedule. No worries, no issues at all. Got it? Fine. Let us wind up. Okay, so thank you so much guys. Thank you so much for the energy you have maintained. At the end of the session, my energy is also drained. I didn't even had lunch also. But just after this, I need to have something. Then I will run away to home. Okay. So see you guys. Thank you so much. Bye bye.